Uh, so everyone, welcome. Thank you for joining us. This is the Energy Showcase, hosted by Deep Tech Showcase. We're really excited about it. We have a really good lineup for today and a really good set of panelists. So this should be a lot of fun. So today's agenda is we divided it out into two sessions. Each session is an hour and a half long. We have, I believe we have 13 or 14 companies presenting, so it should be a pretty interesting experience. And there's a lot of energy technologies, battery technologies, really fascinating breakthrough technologies that are going to be presented today. The vision of Deep Tech Showcase, the reason why we exist is because we want to help companies that are developing these cutting edge technologies make it past the innovation valley of death, to use the over dramatic term, that industry kind of, or not industry, but government puts to it. So how we do it is in a few different ways, and I'm about to break that down. So we've created an ecosystem where startups can reach out and get a hold of and talk to tech scouts from both the government side and the corporate side, as well as investors. So we do this in two different ways. One way is we have showcase events. So each month we have a different event. This month is energy. Next month is going to be autonomous systems. After that is space. After the events, we don't just sit around, although that would be fun too, but we also do guided introductions. So if an investor's on this call and says, hey, I want to see more energy companies, or I want an introduction to an energy company that presented today, first of all of the email addresses, or a lot of the email addresses, are going to be provided in the presentations themselves. Second of all, if you don't catch it for some reason, feel free to reach out to myself or Brian, and we will make sure to send it over to you and make that connection. So in addition, if you are an investor on this call and you want other kinds of deal flow, so you want to look at aerospace companies, we're always happy to talk. The same goes for government and corporates. So these are our two upcoming showcases, as I mentioned. Feel free to take a look at our website and register if you'd like. Now, without further ado, I'd like to introduce Mitch Gold. He's part of the business development side of Eagle Point Funding, who sponsors these events. So Mitch, the floor is yours when you're ready.
Thank you so much. Thank you for the introduction, and thank you everybody for joining. Again, my name is Mitch Gold. I work here at Eagle Point Funding on the business development side. As Asher said, we work with helping deep tech companies secure the research and development funding with the US federal government. So that is our main avenue, and we do that in two ways. But first, I do want to say my QR code is here. If you want to scan it, you can go straight to my calendar. My contact information is here. If you do have any questions, I'm happy to answer any of them, so feel free to reach out. So the way we work at Eagle Point, we do a few main things. So the first is identification and navigation. So we have our consultants take a look at the company's technology and pair it with all of the relevant grant opportunities that are out there. The second thing they do then is the grant consulting, the grant writing, and the project management. So we are here to help you with the building out the templates, with the actual writing for your application, and the project management of it all, because it can tend to be an administrative burden. So we can really help you through that process from start to finish. And our consultants are great, and they really do know how to tell the story of your technology in the most concise and compelling manner. The way we apply, it's not only to one or two agencies. We like to call it a multi-submission strategy. So we apply to a number of different agencies for the highest ROI. You can see on the bottom just a few of the agencies that we work with, but it's not limited to this. You can see some of them: the Department of Defense, NASA, National Science Foundation. So we would be applying to all of the relevant opportunities. Just to speak about fee structure, the way we work is split up between a consultancy fee and a success fee. So our consultancy fee is split up between 6 quarterly installments of $21,000, totaling $126,000. And the success fee is 5% equivalent to any of the grants we help you win. However, this is what we call our ROI guarantee. which is that contractually, our goal is to raise you $1 million as a minimum expected outcome in research and development federal funding, or we will work for an extra 12 months for you for free. We also do partner with VCs or certain incubators. So if you do have a portfolio that you have a number of companies you would like to speak about, we're happy to create some agreements there as well. But that's basically me and Eagle Point. Again, if you have any questions, feel free to reach out, and I will hand it back over to Asher.
Thank you, Mitch. And yeah, feel free to leave your contact information in the chat as well if anyone doesn't catch it. Without further ado, let's continue on. So we have a lot of really good presentations today. I'm not going to read them out loud now because you will hopefully see them in person. So this is session 1, this is session 2. Now I'd like to quickly just, say hello to the panel and have, them quickly introduce themselves. And no funky question today, but just a quick introduction, why you're here, what potentially what you're looking for is a good ad. And then we can continue going. So I don't know. Let me just check one thing. All right, Phaedra, you want to go first?
Happy to. Hi, everyone. My name is Fedrick Crusos, and I'm the Chief Strategy Officer of the Libra Group, which is an international business group that owns and operates 20 companies around the world with assets in over 60 countries. We have 3 energy companies, mostly solar, wind, and biogas in Europe, North America, and Latin America. And one of my kind of mandates at work is to identify how to best manage our existing assets in the most forward-thinking way. So think kind of robot inspections for wind farms and the like, and also to think about what are the assets of the future in our field. So if we're in wind and solar, primarily, do we want to move to green hydrogen or other types of renewable energy sources, or do we want to move even to ancillary things like battery and grid resilient technology? So thanks for having me, and I'm excited to see these companies.
Thanks for joining. Absolutely. Adarsh, you're up next.
Hey everyone, my name is Adar Saukar and I work for Saint-Gobain Nova, the corporate venturing group of Saint-Gobain. For those who don't know Saint-Gobain, it's a French material science company, about 55 billion in revenue, primarily operating in the construction sector, providing different sort of building material products, focusing on light and sustainable and energy efficient construction products. And then the second sector of focus is decarbonization of heavy industries. On the venture side, we primarily look for early stage startups addressing the climate challenge, both on the industrial side and on the construction side. Saint-Gobain also is interested in decarbonizing and getting carbon neutral of Saint-Gobain, internal operations. We have about 1,000 manufacturing plants globally, so a lot of different opportunities to decarbonize our own operations as well. So yeah, happy to be here and looking forward to the startups.
Happy to have you. All right, Matthew Cohen, you're up.
Hey everybody, Matt Cohen of Clean Energy Ventures. For anyone unaware, CEV is a venture firm investing in startup companies that can significantly reduce CO2 equivalent emissions. We typically lead seed Series A type deals and invest across energy, sustainability, the circular economy, and many other related sectors. So excited to be here.
Thank you for being here. We definitely appreciate it. All right, Tim Jones, you're up.
Hey, Tim Jones, located in Colorado with Innosphere Ventures. We're a pre-seed, seed, Series A venture capital focused on climate tech, life sciences, and B2B SaaS.
Perfect. Thank you for being here. All right, Judy, your turn. I don't think we can hear you. Is it just me?
I can't hear either, not just you.
Okay. Judy, if it's okay, we'll come back around to you. Once you have the mic sorted out, we'll just we'll come back. Okay. All right, cool. John.
All right, can you hear me?
Yes, we can hear you.
All right, great. So John Zakowski, I'm the Assistant Director of the New York Angels, which is one of the world's largest and most active single chapter angel groups. We typically invest in seed and Series A companies. And while New York Angels as a whole has expertise across the board and invests in pretty much everything, I personally have an interest, I should say, in clean tech hardware as well. So that's why I'm out here today, interested to see what's going on in this space.
Awesome. Thank you for being here. All right, Rinat.
Yes, thank you. Thanks, Asha. So it's great to meet everyone. My name is Renat Yogev, and I'm a partner with GM Ventures, which is the corporate venture capital arm for General Motors, and based in Israel. And the venture side looks to invest in disruptive technologies that align with GM's vision. We focus on 4 main pillars around electrification, around connecting to the customer solutions, autonomous experience solutions, both for the vehicle as well as for the enterprise, and then digital solutions, which is quite broad. We invest really across the gamut of different areas, whether it's logistics, AI, cyber, data, sustainability, and energy. We support GM in its entirety, which includes its logistics business, financial services, insurance, energy, and fleets. And that's aside from the business. As a first equity check, and with every investment we make, we also look to partner with that startup and develop a strategic partnership with them, and so look to engage also in the commercial side. So that's a little bit about us.
Awesome. Thank you. Thank you, Rinat. Thank you for being here. We're excited to have you.
Likewise. Thank you.
Matt Morris from Vectors Capital.
Hi, everyone. Matt Morris here. I'm currently the associate with Vectors Capital, and we are an early stage venture fund focused on the deep tech side of climate, trying to advance technologies out of the lab and into the marketplace. In terms of where we predominantly look across all climate tech, as so long as it has industrial scale applications, typically with B2B opportunities. And we invest from pre-seed, seed, and Series A.
Perfect. Thank you, Matt. All right, Nicholas King. Or actually, it's I know Nicholas had someone attend on his behalf. Let me just Daniel Hill. Daniel, you want to quickly introduce yourself, or should we come back to you? All right. In the meantime, Judy, you wanna see if the mic works now?
Is this working?
Yes.
All right. Great. Sorry about that earlier. So my name's Judy. I am with Energy Foundry, which is an early stage venture fund. We also invest in Series A companies across material science, hardware, software, technologies, all focused on climate and sustainability. So lots of shared themes here. But we are really looking for things that are anywhere between the late prototype stage to early revenue. And so really excited to be here and hear about cool companies presenting today.
Awesome. Awesome. All right, Leisa, you're up.
From GC Ventures. We're the Boston-based corporate venture team of PTT GC, which is Global Chemical. And that's a $15 billion refinery in Thailand, part of PTT Group, which is the National Oil and Gas Company of Thailand. So we tend to invest in advanced materials, clean technology, life sciences, and industrial digital. And I don't even say what series, what stage anymore, because, seed, Series A is all kind of blurred now. So we just sort of say, if you're at where we need, if we're at where you need, we'll make an investment. Our team also, though, looks for collaboration potential. So if you're at a stage where either you're not raising, but you have technology that's interesting to GC or our family of companies, we have about 30 some odd portfolios beneath the GC corporate. we can facilitate that as well. And GC is kind of interesting because we actually own half of NatureWorks. I have to say that because no one knows that we own half of NatureWorks with Cargill. So we're deep in the biopolymer space as well. And we also can look for technologies on behalf of our sister CVCs. Within the PTT family, there are a number of them. So I'm here basically on GC's behalf, but if you're doing something we think is interesting to a sister CVC, we'll pass that on to them as well. Thanks.
That's awesome. Perfect. And Mark, you're up. Mark.
Hi, I'm Mark Draco with the Chemical Angel Network. Chemical Angels invest in companies that have a chemistry component to the value proposition. I like to call it the 3 M's: materials, measurement, manufacturing. On the manufacturing side, we'll do water purification to solar cells. Measurement, we'll do standard analytical equipment to medical diagnostics. And on the material side, fuel cell membranes, again, water purification, and underlying all this, we'll actually do a little bit of bio and med device, provided there's that chemistry tie-in to the company. And looking forward to the pitches today.
Awesome. Thank you for being here. All right. So without further ado, thank you for all the panelists for being here. We're going to kick it off with EVTronics giving the opening presentation. From EVTronics, we have Paz. Paz is going to be presenting the slides, and then hopefully we'll have Dan presenting the presentation. So feel free to start sharing whenever you're ready. You should be able to share.
Good afternoon, everyone. Can you hear me okay?
Yep, loud and clear.
I'm Dan Vogler with EVTronics, and let me bring up my slide presentation here. There it is.
I can do it if you want, Dan. He says it's okay.
Here we go. Great. You can see that deck?
Yep.
So electric vehicles is growing fast in the automotive segment, somewhere between 20 to 40% per year for electric vehicles, depending on which manufacturer you're talking about. And the shortcoming for consumers in electric vehicles is the charging infrastructure, which is our specialty, not the batteries, not the vehicles, but the chargers themselves. And that's where the opportunities lie. We have a whole portfolio of intellectual property that lower cost, add features, and differentiate our product from other manufacturers. Touching on what some of that is, we have a focus on reliability and pricing. And we have a technology that's generally called carbitrage that will be a real-time market mechanism for electric vehicles to, just as you shop for the lowest price of gasoline today, allow you to shop for the lowest price of electricity on a charge-by-charge basis. Texas, where we're based, is an ideal place for this because the ERCOT trading market has real-time mechanisms to implement this now. So potentially, it could lower the cost of charging your car, which is about 60 cents per equivalent gallon for the range you get today, much better than gasoline, to 1/10 of that, 6 cents per equivalent gallon for the range you get, and potentially with the other energy attributes of carbon credits and renewable energy credits, potentially a person could charge their car for free when we have an excess of power, as is in Texas or around the world in the middle of the night. There's an excess of generation capacity that sometimes goes wasted, which we leverage with our technology. Global standards are evolving as we speak. Interestingly enough, 2 months ago, General Motors joined the Tesla charging network and is moving from the CCS, the Common Charging Standard, to the North American Charging Standard. And the following week, Ford, and in recent weeks, Nissan, Audi, BMW, everyone but Toyota and Volkswagen is joining the Tesla coast-to-coast charging network because Tesla has 17,000 chargers anywhere in the United States. You can find a Tesla charger in less than 200 miles and continue your cross-country trip. So in any case, there's some opportunities around the change of the standard, which we're on top of. Our company owns 7 electric vehicles, so we have a good mini fleet of our own to develop around. And one thing that I'm focused on, I call it level 2.5, to bring down the cost of rapid charging, fast charging, supercharging. These big chargers, which are the size of a deep freeze, are about $30,000. We're going to bring it down to 25% of that cost and make it more feasible to deploy at every gas station in the country and every rest stop in the country. Another interesting technology is called vehicle to home. There's enough energy capacity, typically 50 kilowatts or more, in your car to power your house for a week. We've had 2 serious power failures on the ERCOT grid here in Texas in recent years. And if your car is idle in the driveway or the garage and you can keep your home running versus being in the dark, this is a good secondary use of the battery in the car, which represents 25 to 30% of the cost of the car. We also have a focus on large electric vehicles, buses, trucks, and military vehicles, which are defined as 150 kilowatts on up, that there are really very few players in that marketplace today in that size. Here's some big trucks. We're going to see a continued trend for large vehicles. There are some technical hurdles there in terms of the electric supply. This typically takes 480 volts 3-phase to get that much energy, which is beyond the capabilities of any house in most small commercial buildings. We also have a test system to test not only the electric vehicles, but other charging systems. The current standards are, I don't want to say they're ill-defined, but they use kind of an older technology called J1772, which is not a digital technique, but a analog mixed signal technique to allow the charger to handshake with the electric vehicle and then engage itself. We've seen some problems there, and we have a test jig, and we'll be providing test services for third-party test services for other charger manufacturers and vehicle manufacturers. Now, the military has a mandate to move to electrification among regular vehicles, Jeeps, trucks, and cars, but also large vehicles is definitely a challenge. We're at the beginning of that development phase, and we're looking at the military to be a potential customer for our products.
30-second warning.
Thank you. That there's a intersection between solar energy and electric vehicles, that there's been a survey done that 90% of people with solar on their home also own an electric car. So if you're a green advocate, you really want both solar and electric vehicles. And there is an intersection there where potentially instead of driving your vehicle on the electric supply from the utility, you could be driving your car on sunlight. Now, where we are right now, we have prototypes of several products. I have 3 patents in the works now with provisional patents. We are working on an OEM supply agreement with a major manufacturer to deliver 70,000 level 2 chargers next year. I am self-funded now, so we're not desperate for money, but we are looking for a $3 million an angel or seed round to finish 3 patent applications, which are fairly costly, and go on a roadshow to develop our market position. And here are the team we put together, people I've been working with for some years now, and that's the EVTronics, based in Austin, Texas.
Thank you so much, Dan. So just to remind all the panelists, just so that they're aware, what we'll do now is we'll have questions based off of the order of hands raised. So if you look at the bottom of your Zoom bar, there's a little smiley face with a plus on top of it that says reactions. If you click that, it can say raise hand. So feel free to start raising your hands when you're ready, and feel free to ask Dan and pause any questions you might have. Perfect, Matt, go right ahead.
Sure, I'll get things started here. Could you just quickly summarize what you're doing that is particularly, I guess, unique and defensible here? Obviously, there's a lot of EV charging startups and established players. You mentioned Tesla has a big 17,000 stations. But yes, so what is the unique flavor that you bring to this, and why are you really excited about that? Or why should we be excited about it?
Well, the EV chargers that I've evaluated today from my competitors are not as heavy duty as they should be. I've blown up more than one of them for not being ruggedized as they should be. It has to do with the disconnect relay. We're oversizing everything and offering a 8-year warranty or lifetime warranty, depending on the price point, for our EV chargers. So a focus on reliability. There are also some simple features that we're working into a standard level 2 charger called top off, courtesy charging, time of day charging. Probably the biggest one is the arbitrage, or the market play, where the charger will automatically shop for the cheapest electricity in what's called a pool. If we one car is 6.6 kilowatts is the charging energy. That's not that much. But if I pool together, virtualize 770 cars and pool them together, 770 times 6.6 kilowatts is 5 megawatts. This is the minimum energy charging block to buy wholesale in the Texas ERCOT market and other trading markets around the country. So by cooperating with other EV owners, we can get the price down to 1/10 of what it is now for electricity, or even potentially zero. I think that's one of our biggest value propositions, is the arbitrage. Arbitrage is important to a combination of car and arbitrage.
All right, perfect. Rinat, you're next, then Adarsh. And I think Adarsh will be the last question for this pitch. So Rinat, go ahead.
So Dan, thank you for the overview on EVTronics. So my question is, what role does EVTronics play, given that, automotive OEMs are also developing such technologies themselves around the charging and energy storage?
Well, we are ramping up with our manufacturing capability for a unnamed company that will be importing into America next year, but we have some proprietary patentable intellectual property I hope to be able to license to the industry across the board.
I'm just going to add as well, we're especially with Dan's knowledge of the electronics behind it, we're also oriented towards providing custom installations, beefing up the existing charging networks for those who don't own Teslas. So we're partially participating with Eagle Point, so we can identify some of the requirements that are needed for these non-standard, not just home to car application.
Maybe I'll go next. Yeah, Dan, just to elaborate on the differentiation, you briefly mentioned about your patent. Can you elaborate what exactly does the patent cover, and is it just the hardware, or is it hardware and software, and sort of what's defendable and how many
Well,
patents?
the arbitrage approach, the market-driven mechanism is kind of complicated. There's 5 different players involved to make that work, and considerable front-end and back-end software, as well as some specialization in the charger itself to automate and shop for electricity automatically at the lowest price in the middle of the night. So that is I think at the forefront of our patent roadmap is the arbitrage. In addition to that, I mentioned vehicle to home. There's also a broader concept called V2X that the battery in the car can do a lot of things for us. It can power the home. It can provide ancillary services to the utility itself, or it could even charge another electric car. So V2X is a catch-all term, which means V to home, V to grid, and V to vehicle. So the battery can not only propel the car forward, it can do 3 other functions as well. And we have defined some standards and mechanisms for that to work across the industry, because I think that will be a differentiator for many manufacturers to power the home and provide emergency backup is, I think, another reason to buy an electric car.
Perfect. Thank you so much. So Dan and Paz, make sure to leave your contact information, at least for the panelists in the chat, or if you want to share with everyone, you can as well.
You know, and I don't know what went wrong here. On the final slide, that's not the email addresses we updated. So
yeah, we'll share them.
Yeah, it's Dan Vogler at EVTronics with an X.com, Paz at EVTronics, and Anil at EVTronics, our principal domain name. I apologize for that.
I'll chat them right now.
Yeah, absolutely. Yeah, and if anyone wants to connect, just feel free to message myself, or you'll get it in the chat as well. All right, perfect. Next up, we have a Clarity. Feel free to start sharing your screen whenever you're ready, Jared.
Yeah, sure. I can start sharing right now. Is it sharing? Hope so. Right.
We see it, but it's not on presentation mode yet. It's like the editor mode.
There we go.
Yep, there you go. You're good.
All right, so we are a Clarity Water, and we are an environmental biotech organization that focuses on, as it says, we do destroy PFAS forever. I think everyone hopefully has heard about PFAS, and certainly the community as a whole through popular Hollywood movies has talked about kind of PFAS and kind of where it goes. From a quick standpoint, again, PFAS, as we understand it, is everywhere, harmful to the environment, from the bonds that kind of go on in there, and it does do a lot of destruction. You can kind of see on the left-hand side where it does impact, from pregnancies, and it is a cancer-causing compound as well. PFAS is synonymous with its 3,000 kind of best cousins. As we dive more and more what we call contaminants of emerging concern, they've been around for a very long time, and thankful that the compounds like PFAS, we have waterproof rain jackets and Teflon in your pans. Even the couches you sit on are held together by some sort of a PFAS related bond. It's really that strong carbon fluorine bond that really hold up all those things together, and it's everywhere. It's in all of us. It's in most of our basic things we use every day as well. So the whole idea right now is, thanks to the public outcry, is how do we really, after products are being utilized, how do you make products that don't use PFAS, but more importantly, once products that have PFAS are done with, and instead of putting those products back in landfills and discharge that liquid back out in the water, how do we break that cycle and really destroy it overall? Overall, if you look at kind of where PFAS is, this is a snapshot of things going over in the the European side of things, it's everywhere. Again, there are hotspots. You have leading places in the United States that are leading the way with regulatory perspective. Vermont, Maine, Michigan, to name a few, have some of the strongest PFAS regulations out there from a drinking water standpoint on what kind of concentrates out there. Again, movies like Dark Waters, for example, have really highlighted the contamination that has been going on for decades out into the water. And again, up until now, PFAS has been looked at from a disposal standpoint. How do we dispose of it, but not really mitigate it and destroy it? Traditionally, your PFAS gets disposed of. It means that it'll get bound up onto some other media. Think of like a sponge. You can actually take PFAS and soak it up onto a media such as ion or granular activated carbon, for example. But then you have this concentrated version of PFAS that is just there. Hasn't been destroyed of. It's just been moved and kicked down the road. So, trying to put that liability, that responsibility down on someone else down the road, essentially. And you look at kind of what the, what's going on and kind of the costs out there. It can go, disposal costs are wide depending on where you are in the world. And traditionally, we look at, absorption versus destruction of PFAS. Usually look at incineration to really destroy PFAS overall. Again, which is adding a lot of heat and potentially burning it at a great high cost, not very sustainable in the way you look at getting rid of it overall. So at Clarity, we have developed a technology called electrochemical oxidation. Electrochemical oxidation isn't new. It's been around for a long time in the water and wastewater spheres. Essentially, what you're doing is you're running, some sort of PFAS contaminated liquid through an electrode, and on the right-hand side, you see a picture of an electrode, and you apply a proprietary coating to that electrode, a gap between there, and a voltage over it. Essentially, because chemicals have a polar bond in them, you disrupt that polarity, and you mitigate and you break the carbon-fluorine bonds, resulting in carbon dioxide and fluorine essentially in their naturally occurring elements, and then you discharge what's going on through your normal discharge purposes at either manufacturing facility or a wastewater plant overall. So again, this is kind of more of a pictorial standpoint of what's going on as you break down those bonds. Again, we focus a lot on landfill leachate. Leachate is what comes out of landfills, and it has a very high concentration of PFAS overall. Think about all the things you throw into the trash that end up in a landfill, and that's why there's such a high concentration of PFAS in those areas. And as those compounds break down, they produce a water and also a gas. And the water, which we call leachate, is what we go after. But essentially, you take your contaminated soil liquid, that liquid is absorbed onto the anode surface. The free electrons break down, again, resulting in carbon dioxide, fluorine in their mineralized elements. And then you look at high oxidation radicals to really break everything apart. Again, for those that are familiar with oxidation, kind of what it is. UV radiation, which became very popular during COVID for disinfecting, which is really a misnomer for it. It's actually deactivating, is a way of creating oxidation radicals with UV light, essentially.
30-second warning.
So what do we look at overall? When we have kind of that piloting, and then we go from a full-scale standpoint as well. We are the only technology, PFAS destruction technology in the world that has full-scale installations that are scattered out through the United States and also our mobile deployment systems that deal with AFFF and foaming and some other fun stuff out there. On the bottom right-hand side, you can't see it. Maybe you can, but there's kind of a picture of what it looks like when you go through Clarity. Overall, you can see the kind of that color reduction. And we go to market as a service-based organization. Instead of providing capital equipment, we provide services. So we do it on a cost per gallon treated. Typically, and we are adding electricity. It's not massive amounts. Think of like a 60-watt light bulb and put it into a gallon of water and leave it for an hour. Those are kind of low electrical costs we talk about. And in general, when you look at the service-based model, the service, electricity, the CapEx equipment, usually we are somewhere in less than, say, 20 cents a gallon per gallon treated. When we start to look at options out there. This is kind of a table of
we should start wrapping up soon.
Yeah, so this is I think it's the last one. This is the one that shows all the other technologies out there: activated carbon, incineration, water, that kind of show what's going on between some technologies. And this is the major areas where there are PFAS: landfills, wastewater plants, aviation, drinking water, overall. And that's, in a nutshell, that's what we are all about. That's all I got.
Awesome. Thank you so much, Jared.
Sure.
Yeah, and for the panelists, feel free to start raising your hands. Adarsh, and then Leisa.
Okay, hi. Thank you. Just a couple of questions.
Sure.
I think you mentioned on the concentration levels. Can you provide more information on what sort of the concentration level or range that needs to go input, and then two, what's sort of the time required to completely destroy PFAS? Is
Sure.
it like a continuous cycle? Yeah, I think those are the two questions I have.
Yeah, from a starting concentration standpoint, it really doesn't matter. We can destroy up to 99% of PFAS overall. The higher the concentration, it just matters of going through multiple passes of equipment or a longer residence time. Typically, your contact time to treat PFAS is usually seconds. So again, we typically run about 30 gallons a minute per reactor, and in that quick time frame is when we destroy all their PFAS overall.
Okay. And sorry, one other question. You mentioned about some of the pilot project. What's the current scale at which you're operating?
Our pilot systems operate at 2 gallons a minute, and then a full-scale reactor system operates at 20 gallons a minute.
Okay, and you're currently at a scale where you can have some pilot projects deployed?
Correct, and we currently do. We have 4 or 5 pilot projects running around the United States and throughout Europe currently, and we are the only technology out there with a full-scale installation of destruction in the world right now.
Okay, I think we probably might have some pilot opportunities. So let's connect offline on that.
Yeah, sure. And we do piloting. We also do mobile bench testing too. So yeah.
Okay, thanks.
Yeah.
Perfect. Leisa, you're up.
So I have a question about your technology in terms of, so PFAS is a family of chemicals. And so how do you know you're destroying all of them? And then how do you know you're not creating any co-products that were unanticipated? How do you test for that?
Yeah, so when you look at PFAS and say it's 3,000 favorite cousins, right? Typically, you look at, say, what we call the Mass 6 Vermont 5. So some of the most commonly regulated PFAS, PFOA, PBXH, some of those main compounds that the United States EPA has really targeted in our testing. So when we go out and test, those are the ones we really test for. And there are client specific when we look at it. We look at oxidative potentials. A lot of them act similarly to what's going on. But to answer your question is, we just find out which chemicals you are interested in and test for those through certified labs, essentially. And then from a compound reforming standpoint, when you break across those polar bonds and they go back into their original forms, they really won't reform, again, because we're not oxidizing, we're not adding a lot of heat to the system. It's not like you're taking say an onion and then totally baking the onion and changing its characteristics. We're breaking it back down into its natural elemental forms that don't then recombine to do something else with, essentially.
Perfect. Tim, you're up.
Yeah, hey, thanks. Just a quick question on the study that was released by, I think, Northwestern last year. Do you care to comment on at least the way it was positioned as being a fairly easy, low cost way to remove PFAS?
Yeah, I think easy is the great way to kind of look at it in that standpoint. When you look at electrochemical oxidation, while the technology is very robust and has been around for a long time, you look at the main factors that deal with destruction overall. It's more flow and concentration and where you want to get down to, and because you're not adding a physical barrier with this type of technology, your limitations are really coming down to, can you pump it or not? If you can pump it and go through the electrodes, then you know, you can pretty much treat it that standpoint as well. It's kind of the overall summary of it.
Thank you.
Yeah.
Perfect. Mark, last question.
Yeah, I'll make it real quick. What sort of efficiency are we talking about? Not at the, high levels of PFAS, but something more in the, sub-part per billion level. What's your electron efficiency?
From an electron standpoint, I'd have to get back to you on that one. I will tell you from an overall treatment standpoint, we're about 40 kilowatt, we're at 40 watts per hour gallon treated is kind of what it comes down to be on efficiency standpoints. But we can certainly talk offline if you want to get in more detail on, electron transfers and kind of how that goes about.
Yeah, just really interested at the very lowest PFAS concentrations, what the efficiency.
Yeah, and again, that when we say like kind of that 50, watt hours, and that's a very, very high concentration, you're talking, 60 to 100,000, nanograms per liter type concentration on the high end of things for sure. Yeah.
Perfect. Thank you so much, Jared. Make sure to leave contact info or whatever you're comfortable leaving in the chat.
Yeah.
And if anyone else can't get through to him for some reason, feel free to reach out to me and I will try to make any connection needed. All right, next up we have Carbon Ridge.
Hey guys, thanks for having me.
Absolutely. Yeah, feel free to share your screen whenever you're ready.
Yeah, sure. Let me just pull it up here. All right, do you guys see my screen?
Yep.
Great. So nice to meet everyone. I'm Chase Dwire, co-founder and CEO of Carbon Ridge. We're a Santa Monica and Houston-based technology developer of carbon capture solutions for the maritime industry. So in essence, we develop a point source carbon capture solution that retrofits and builds into new shipping vessels, think container ships, product tankers, bulk carriers, that directly reduces the emissions from the flue gas. And so we founded the company, myself and two partners here in Santa Monica, really for two reasons. A, the shipping industry is a significant decarbonization opportunity that has really been underserved. So, you have 90,000 vessels trading globally, which represent about 3 gigatons of emissions. And, the other component is that while there's been a lot of solutions proposed for maritime based off of alternative fuels, alternative propulsion, looking at electrification, the fundamental issue is that for maritime, there's two large issues with alternative fuels. The first is that the energy density of them is not compatible with this industry. And the other element is that the cost to scale those fuels, within the next decade, 3 decades, to get a low carbon methanol or a low carbon ammonia is going to be prohibitive for the industry. And really the reason is that, right now the maritime industry, it chooses from the bottom of the barrel, right? So it's the lowest refined product out there. And what you're asking them to do is go buy a highly refined product that's kind of above the level of SAF. And so the dynamics of it are not very well fit for the next few decades. And so what we looked at is, okay, is there another solution that can achieve the same level of CO2 removal or the same reductions, but at a cost that's significantly less and more scalable in the near term? And so that's when we started looking at carbon capture. And when we initially looked at it, while carbon capture is a much better solution, the conventional approaches and what have been proposed for carbon capture using this column-based structure that you'd see in refineries is going to have significant issues with both efficiency and cost. And the reason is that those columns are built for stationary environments where there's no movement or vibration. And so when you put those onto a vessel and translate those to a moving environment, what you start to see is you see significant effect in efficiency based on what the columns move around. And they're also very space intensive, right? As you can see from this kind of skid module, is that you have to replace a number of containers and you really kind of have to reconstruct some of the vessel systems in order to fit it in. And so for really the kind of operational efficiency perspective and the cost and kind of invasive nature of them, we didn't think it was a great solution. And so what we did was went out and developed a much more modular approach that uses essentially centrifugal technology at its core, using process densification to significantly scale down the system. And so in essence, what we use is kind of like a glorified centrifuge to take that 20-meter column and reduce it to a 2.5 to 3 meter centrifuge in diameter. And that's what does the core capture process. So we run the gas through that system, and it uses basically a centrifugal force to capture the CO2, binding with an amine solvent. And what that allows us to do is, we reduce system size by 65 up to 80% of the process equipment. And the other key component is that because of the centrifugal force that those contactors are using, you don't see any effects in the maritime environment largely, because the gravity force that's pulling at 600 to 1200 RPM is more than any tilt or vibration that you'd see on these vessels. And the vessels already use centrifuges for gas cleaning, so we know that operationally they're proven. So that's really kind of the core part of our process. The way that it works is that we reroute the exhaust gas from the funnel. We then have a pre-treatment process to take out kind of trace pollutants that are also in the gas. That treated gas then goes into our first absorption section where the CO2 is removed in these key contactors. The CO2 and the solvent that's now bound together is sent to another one of those contactors to be regenerated. So the solvent's separated and sent back to the first part of the process. It's kind of recycled every time. And then the CO2 is now in pure form, compressed, liquefied, and sent to tanks for storage for the remaining part of the voyage. And so that's really the kind of core capture technology on board. The other element of this solution is that once you've captured the CO2 on board the vessel, you need to figure out, okay, how are we going to handle this on the back end to make sure it gets off the vessel and to a final end use, whether that's sequestration or utilization in concrete, for instance. And so what Carbon Ridge does so that shipping customers don't have to do this on their own and kind of not focus on their core business is take care of this model for them. So we're partnering with both groups in the shipping industry on transportation and groups in the oil and gas industry, and kind of the up and coming climate utilization industry to partner on both of these pieces and deliver an end-to-end solution for our customers where we sell the core equipment and the capture process and then provide kind of a service model on the back end for them to take care of the CO2. And what that leads you to is, as I showed in the first slide, a significant cost decrease in comparison with alternative fuels. And, even if you're comparing it to kind of maybe more available products right now, you still see a significant spread in between the two. And this is kind of at scale of our first generation system. Right now, we validated the contactors for, high levels of CO2 removal at pilot scale. And what we're working on now is developing, a full scale or a commercial or pilot scale product that will go on board a container ship in the early part of next year. The system is fully engineered and being constructed right now, and we'll be testing it on land in the first part of January, and then it'll go on the vessel, at late first quarter of next year. And that's going on with Crowley, which is the largest US-based shipping company, in partnership with the U.S. Maritime Administration. And really after that, we plan to scale the technology, go build 2 commercial scale systems initially, and move from there with our initial partners. Crowley and Bulk are 2 large private shipping companies that were first investors, as alongside the Grantham Foundation, which is a family office venture capital firm that invests mostly in climate. And really, we're planning to scale kind of initially with Crowley and Bulk as our 2 kind of core customers, and then we have a number of traction with other larger shipping groups like CMA, Maersk, groups on the product side like Scorpio Tankers, and a handful of others. But really, our approach is work with a select group of partners that have skin in the game with us, scale the solution with them, and then go expand to the broader market. So that's kind of the summary. We are raising right now, so happy to talk with people about that offline. But that's kind of the overview of Carbon Ridge.
Thank you, Chase. John, I see you already have your hand up. So John, then Phaedra, then Matt.
Yeah, so you kind of jumped over the team slide, and I would be interested to know about a bit more of the experience of the team, particularly as well with the shipping industry.
Sure. Yeah. Sorry to jump over that. Wanted to be considerate of time. Yeah, so we have built a really strong team. I partnered with Jorge and Justin really when I started the company in it was really kind of fall of September 2021 after I partnered with Jim and Jeff. So Jim and Jeff are longtime investors in climate. They run a firm called Racine Capital Management where they mostly invest their own money. But they're first investors in carbon engineering alongside the Gates Group. And they've run a number of other companies kind of in desalination, low carbon fuels, really across the space. And then so we partnered with Jorge and Justin. Jorge's got a PhD in carbon capture from the University of Texas. Justin's been in the shipping industry for about 30 years. So he runs business development for us. Jorge leads our technology development. And Mariana is our lead naval engineer. So she does everything from certification of the classification societies to helping us design new systems on vessels, et cetera. So small team right now. We mostly work with us internally and then work with external engineering firms to help us build our system. And what we're in the process of doing this fall is scaling out our team a little bit more to help us with R&D and commercial scale engineering work.
Thank you.
Perfect.
Yep.
Phaedra, you're up.
Great, yes. Hi, one of the 20 companies at Libra Group is a shipping company, and we've got a nice container shipping fleet, and we are looking at carbon capture. What we're finding is that the cost is pretty up. We're looking at a variety of technologies, and we're looking at the cost of their technology. So if you could give me an idea of how much it would cost to retrofit onto the ship, and then how much any materials like ongoing costs would cost for something like this. It'd be great to know.
Yeah. Sorry, I'll just pull up my screen quickly while I talk, but I didn't realize I wasn't sharing the team slide earlier, so I can send people this deck. So overall, we're looking at, we try to look at it really on a life cycle basis on what it costs in comparison to the fuel premium. So this wraps in the CapEx plus the OpEx cost. So first generation system, we're looking at about $100 a ton captured, which equates to, this is from an MR tanker. It equates to about 10 to 12 million in CapEx. And then looking at any kind of utilization of 45Q, this is based in the US or the European ETS, or for instance, selling into cement markets. You're looking at, about a $66 a ton costs down to kind of $40 a ton, depending on those utilization markets. So kind of unsubsidized, we're looking at about $100 a ton. And, let's say 10 to $15 million in CapEx for the first vessels we're looking at. In terms of an OpEx perspective, it's pretty low because we don't have a significant logistical burden on a day-to-day basis because our solvent is recycled in our process. That solvent gets reloaded about once a year, maybe twice a year in some cases, depending on the solvent we use. And, a lot of because our system is very autonomous, a lot of the maintenance, it's kept kind of a biannual basis or annual basis on what we're doing. So really what we've tried to do is, we've taken a little bit longer of a curve to develop our technology than some of our other competitors, I think, in developing the solution. But this system you see, for our pilot is going to be very autonomous and act like a commercial scale system. And that we're really trying to take out many of the risk elements that's associated with this process so that when we go to scale, there's not all these elements that still need to be proven essentially. And we think that that's going to significantly reduce costs.
Understood. Thank you.
Yep.
Perfect. Matt, you're up.
Awesome. Thank you so much for that. So my question is geared more towards like the operational or like engineering retrofit capability of this. So if you are rerouting the flue gas on a ship, are there certain types of ships that work better for this? Are there already any constraints around modifications that you'll have to make? And then also too, what is the process for actually engineering redesign on each ship, and are there certain models that work better or like certain years of them?
Yeah, so our real kind of goal is to be able to standardize design as much as we can. So we build the reason we've used our technology is that we're able to build modules really, and we use the centrifuges so that you can build a kind of module package so that the core technology does not have to be redesigned for every ship that we're designing for. It's really the skid design looks a little bit different, but the core process stays very similar. So we'll build in classes for different engine sizes, essentially. So you have a 10 megawatt engine, a 15 megawatt engine, and then you have different variants of, okay, does it have a waste heat boiler? What do the auxiliary systems look like? So, you know, and the good thing is that, like with a lot of these fleets, for instance, Crowley has about 10 sister vessels to the one we're doing the pilot on. And those vessels are almost designed exactly the same. And so the P&IDs for those designs look almost identical, right? So we don't have to redesign every time we're doing that. So the one-time engineering turns into spread across 10 vessels. As we scale, you know, we'll kind of come up with a similar pathways that partnering with shipping companies who have large fleets of the same vessels so that there's not that one-time engineering expense. There are some vessels that are maybe not a perfect fit, like for like a LNG carrier that doesn't have a lot of room on board the vessel. Like some of these vessels, they just have almost no space and they don't have space for storage. And they can't, obviously, then you can't store the CO2 in the LNG space. So there are some vessels that are just like fundamentally not very well fit for this type of technology. But that we've kind of excluded that from the, you know, the 50,000 vessels that we think are in this market. So there are definitely some, and there are some other approaches like, you know, some of the solid based approaches using, you know, turning CO2 into calcium carbonate may be better for other vessels based on the way that they trade in some cases. But I think as you scale and as you get to large scale, looking at the infrastructure, this seems to be the solution that wins out in the end from a cost perspective. So.
Thank you.
All right, we won't get to probably every question, but let's try to do as many as we can. Leisa, you're up.
Hi, thanks. So, you know, when companies come to us talking about their carbon capture costs, it usually is based on, you know, at scale. In your case, you mentioned, you know, carbon credits. You mentioned how often the amine will have to be switched out. What other things are factored into that cost? Do you factor in the CO2 has to be sold? Like, what are the other components of getting down to the whatever the $30 to $65 a ton that you mentioned?
Yeah. I mean, I think the logistics and transportation is another element, right? So you can capture at, you know, say first generation unsubsidized $75 a ton, but that other $25 to get to the 100, it could turn into $50, you know, if the transportation model isn't set up well. And so what we're looking at is the sequestration costs. If you're going pure sequestration right now are most likely going to be between $8 and $15 a ton in the Gulf with the majors. And then when we're looking at logistics, this is for Crowley, for instance, we're looking at transporting CO2 from Port Everglades into the Gulf to one of those projects. We're looking at about $10 to $15 a ton. So combined, you're in that kind of $20 to $30 range, at least initially. So those are two big cost elements. And I think the logistics is going to be a big driver of cost, maybe even more so than the CapEx in a lot of ways. And that's why we're going to choose certain markets to work in initially. And as the infrastructure comes online further, then we'll scale from there. And really our goal is to work with existing infrastructure that's coming online. And we know that kind of industrial decarbonization needs to happen by industrial carbon capture, which means that CO2 needs to be transported globally because there's not good geology everywhere. So it's that. And then I think on the CapEx side, you know, some vessels are a little bit more complicated than the others in terms of the existing systems on board. And so sometimes we need to add a few other elements to our system to make sure that it has enough energy or it doesn't use too much energy from the vessel. And so that can sometimes change the CapEx depending on those systems and how they're designed.
Perfect. Sorry to cut this short, but Renat, Judy, and Diana, please leave your messages either in the Q&A or the chat so that Chase can get to them because we have to keep these things moving along. But thank you so much for the presentation. And also anyone who has more questions, feel free to contact Chase directly as well. He could, I'm sure Chase would be happy to answer offline.
Yeah, happy to answer calls or answer emails and have calls as needed. Thanks.
Sure. Perfect. Thank you so much, Chase. Next up, we have Margic. And the floor is yours.
Hello, everybody. Hopefully everything will kick on correctly.
We can see the screen. It's just not in share mode yet. So
it's taking its sweet time.
Of course, it always does, right? There it is.
Here we go. Here we are. So I'm a founder and CEO of Margic. My name is Margaret Kacherga, and we work on energy efficient organic LED lighting. So the core problems that we're tackling are starting with a big picture is there are limited options for energy efficient lighting still, even since evolution of the LED lighting. There are still challenges even with LED lighting, which is currently one of the most efficient options we have available. There's still poor quality and unreliability of these products, from shipment to deliveries to the actual operations of these devices. The high production cost for the novel technologies is definitely preventative for the wide usage of the novel technologies and the poor customization opportunities of these options. So what we are offering is a bit of a holistic solution. So core innovation started with core materials that are utilized to make organic lighting main diodes, such as hole transport, electron transport, so charge transport materials, to first make them more efficient, as well as make these devices more rapidly producing. And for that, we had to design materials in such a way that they can be multifunctional, so less step for manufacturing, for printability options, as well as we do not use any heavy metals or scarce earth materials. And right now we work on a provisional patent for the actual engineering portion of this device for the end product usage, as demonstrated on those little segments in this box, and the motorcycle lighting as our first couple of products have launched in the market. So our technology is capable of reducing CO2 emissions by reducing the stress on the power grid and consuming less energy. So in relation to the automotive use case, we can provide 30% less power consumption and extending that mileage per charge around in the automobile, as well as we have improved sustainability factors within our technology, and we're even considering options of biodegradability in the future. We do have currently a dual use Air Force product in development, which is autonomous lighting that has to be ruggedized for cold, snowy winters and can be taken off the grid during the power outages or those areas where lighting and electricity is just simply inaccessible. Our support to date has been greatly from non-dilutive funding, but we do have some private capital experience raising as well. We have raised through government contracts $1.7 million through NSF and FWorks, but we also have collaborations and works with Department of Energy at Argonne National Laboratory, some accelerators that we were able to start with, and we have raised $200,000 from Reinforced Ventures, as well as a few other angels. As far as competitive landscape, there are some giants like Osram, Oilworks, and such that we're looking forward to maybe future acquisitions. And we are in great relationship with Oilworks. We have done several rounds of testing with them and further development, and we do have a letter of intent or purchase agreement with them, as well as we have some smaller direct competition with other startups like Synovia in the United States and Endure in Germany. And we try to keep the frenemies competition, so we're aware and we have collaborative projects together, but also they're keeping us on our toes to make sure that we are a few steps ahead all the time in front of them. As far as our exit strategy, we are going to pursue acquisition as exit strategy, most likely through either an organic LED lighting company or organic display light company such as LG or Oilworks. As far as our opportunity, our beachhead market is automotive lighting. That's what we're going to pursue specifically in the area of motorcycle and lighting, one-wheelers and etc., and some of the luxury items. Our entry to market is through the luxury items opportunities, like you saw those boxes in the very beginning, and this is the projected revenue from our currently available projects in a pipeline, with ability to grow through the mainstream lighting opportunities up to $1 billion. We do have an amazing STAR team. I love these guys. They have experience from both the organic lighting diode industry, as well as ability to scale the business models and go through acquisition and even the public IPO experiences. Our advisory team is really standing by our side all the time to make sure that we can ask them questions and guide us and help us with some of the things we don't have experience in. And here's just a quick rundown that we are always interacting with the industry and actively pursue some of our purchase orders right now, as well as those letters of support and intent to purchase agreements. We are currently raising funds. We're at the seed stage, $2 million to go through that MVP production and initial launch on market and vet that initial customer and business model before we pursue into the full production. So if this is something that interests you, I would love to talk to you more. Thank you.
Awesome. Awesome. Thank you so much. Renat, you were first one.
Great. No, thank you. Thank you, Margaret. I wanted to ask, what is your core technology? And what does it mean also to be organic lighting?
So organic lighting made diodes are made of organic materials. I'm not sure if your chemistry background is, if none. So we call organic things that belong in your body. So carbons, hydrogens, nitrogens, oxygens. So that's what these materials are made of, those earth abundant organic materials. And even though they are structured in such a way as the rare earth materials that are currently efficient in the market, they are made to mimic it without having to utilize those things.
And regarding the differentiation?
Yeah, differentiation is from two perspectives. So the first perspective is the materials themselves. So we actually had to re-engineer the stack design of the device. So organic lighting diode is like a sandwich where each layer is responsible for one particular job. So our stack design is unique to us only, as well as the material design, but also on the engineering of the end device. That's what our upcoming patent is how that device is actually connected, wired, and all that stuff.
Okay, thank you.
Matt, you're up.
Yeah, so my question is stemming off of Renat's. So you mentioned organic. From a material science standpoint, typically organic, anything here will either have instabilities or be photo unstable. So can you kind of walk me through like the chemical stability of your product and then how long its useful life is actually expected to last for?
Yeah, well, even inorganic materials have to be encapsulated, and that's what typically organic lighting devices have to be encapsulated. There are some very great upcoming options on the epoxies and some derivative epoxies. So we do end up for those ruggedized options having to use encapsulations, but our materials are completely moisture stable and oxygen stable, and they can withstand heat up to 300 degrees Celsius. So from that perspective, initially, those materials are quite a bit more stable than your typical organic materials would be. And what was your second part question? I'm so sorry.
Useful life of the material itself.
Useful what?
Useful life. How long do you expect each?
Oh, yeah. So yeah, right now we are the same life expectancy as current OLED on the market manufactured by OLED Works. So whenever they compared it to their standard, we had the same LD70 performance as theirs for the blue OLED, but we are expecting to push it definitely to the standard of 10,000 hours for the blue, but for the reds, we can achieve further than that.
Thank you.
Perfect. I think that's it on questions, unless anyone has a last question. Otherwise, thank you so much, Dr. Margaret. Feel free to leave your contact information in the chat, and feel free for anyone who wants to get in contact. Obviously, you can either reach out directly or contact through me. Yeah, thank you so much. Next,
thank you.
Absolutely. Next up, we have Terraform. Feel free to start sharing whenever you're ready.
Yeah. Hi, I'm David Smythe, and let's see, you guys can see that now, I hope. All right.
Yeah, we see it.
Okay. So this is what we do. We mine the sky for cost-effective, carbon-neutral methane. Let's go to the next page. There it goes. So the basic vision is to replace all of the fuel generation that comes from the current, pulling things out of the ground, and in fact be able to scale to beyond what can be produced from oil and gas fields. This is a mechanism to store and transport renewable energy as gas, so that it can be created during the summer and used during the winter. And we've designed this system so that it can scale like McDonald's. The only way that you get up to replacing the fossil fuel generation on Earth is by being able to scale dramatically and quickly. So by designing these systems that are easy to build by anybody, there's no fancy materials. The factories themselves are small, 10,000 square foot per factory. Very inexpensive to build out, cheaper than building out a McDonald's, literally. And then this allows the wealth generation of these machines to be distributed all over the world, just like the fuel manufacturing. You make the fuel where you need it. This has some very good economic benefits to the world, as well as political benefits. It depowers the existing dictatorships that are basically funded by their fossil fuel extraction. So the people that need the energy can make the machines, can make the energy, can make the money out of it as well. So it's a local labor and investment, resulting in clean, sustainable energy. We're doing it by attacking the problem in 3 different ways, by making things as cheap as we possibly can, really leveraging the falling prices of solar power, making it as scalable as possible by cutting out some of the things that are slowing the spread of renewable energy. For example, the grid. The grid's not necessary for making this gas. The machines can be hooked straight up to solar panels, to wind too, but solar is where the growth is. And the whole process of getting the fuel and using the fuel is much better than the current approach. We don't need to punch holes in the ground and make all the ecological problems, and this is sustainable forever. You pull the CO2 out and perhaps burn it, and it goes back in, or a fair percentage of natural gas or all hydrocarbons turns into product that is not burned, plastics and so forth. So that is a way of sequestering the carbon without just taxing everybody to do so. It is still in products, so that there's an economic motivation to enable this scaling and this wealth creation. The machines look like this. They're about 100 feet long and about 8 feet wide. This footprint was chosen because it's about the same as existing inverters that are deployed in utility scale solar farms. There's the direct air capture component. There's the kilns, which are kind of the squarish looking blobs at the end of the direct air capture component that takes the sorbent, heats it up, and releases both water and CO2, very concentrated CO2. The interesting thing about this is that just one pass of air through our sorbent material absorbs 70% of the CO2 in the atmosphere. So it is so effective that there's not really a need to hook these things to existing sources of CO2. We can just pull it straight out of the atmosphere anywhere. Then the water and the CO2 that we get out of the sorbent material is fed into the water, goes into the electrolyzers to get us the hydrogen and some oxygen, and the concentrated CO2 and the hydrogen gets fed into a reactor, a Sabatier reactor, to generate CH4.
30-second warning.
Yep. Really? So we hook it up to existing infrastructure. These are the mechanisms involved, just very straightforward and well-known processes. We've already got some traction. We've signed agreements to sell the gas to the 2 biggest buyers in California. Let's see, the IRA is useful for bringing price parity with fossil fuels forward, but it's not really necessary. Within about 10 years, will be cheaper than fossil fuel extraction, no matter what. So we won't need the IRA indefinitely to pull this off. This is where we are. We're in the middle of getting our first full integrated system up and running right now, with full-scale machines available in the spring for pilot projects. And our team has been selected. Almost all of us have deep roots in Caltech, and SpaceX and JPL and places like that. So we're used to doing the impossible successfully. And we've got a great investor team, actually, that's funded us with two seed rounds. We're going to do a Series A in about 9 months. So there we go. I think, did I beat the deadline?
Perfect. Thank you so much, David. So to get going with the question, Diana, you want to start us off?
Yeah, I'll get going. Can you all hear me okay?
Yep, sure. Loud and clear.
Hi, David. Can you tell me, I'm a Director of Research and Development for NOV. Can you tell me a little bit more about the integration of the pieces? You said that the direct air capture is nothing new, the reactor is not really anything new, the electrolyzer is not anything new. I'm assuming that the integration is the unique part. Can you tell me more about that?
The unique part is the extreme low cost of this system. There's no MEMS or any kind of unobtainium involved. It's using materials that are very inexpensive and globally available with very short local supply chains. So that's really the point, is that we can make these things for a tiny fraction of what anybody else is trying to do. We're focusing in on the scalability. So that means easy to manufacture, easy to each factory being very small and cheap as well. So the entire CapEx chain is minimized. No mega factories required.
And a follow-up question, what's the flow rate through the system that y'all can handle?
Each machine consuming 1 megawatt of electricity generates 1,000 cubic feet of gas per hour.
Okay, thank you.
So that's hundreds of millions of machines to replace all of the fossil extraction, but I mean that's about the same number of wells, so it's about that scale of a problem.
Judy, you're up.
Hi, Judy.
Great, thank you. So I wanted to, Diana, that was a good question. That was one of my questions. The other question was going to be on like customer and scale up. And so could you breeze through the traction aspect of your presentation, but how do you see this technology scaling up in like the different phases, and who would you partner with, or how would that be funded?
Our primary partners that we're signing MOUs on, like right now, we're negotiating these things, is utility scale solar developers. Right now, a lot of their growth is being constrained by the timelines to get transmission lines and substations built out. This completely eliminates that timeline, so it allows them to grow faster than they can by going with just selling electricity off of the solar. However, we are finding some very interesting industrial synergies. For example, we've just completed a study with the DOE's iron and steel making modeling system, combined with data that Climeco has through as a third party has come up for our systems, and it appears that we can halve the cost of steel production by leveraging not just the methane that comes out of these machines, but also the oxygen, hydrogen, and steam, so that a small capex increase in the steel mill for a large OpEx, and it also just flat out turns the steel mill industry from a gigantic emitter of carbon to a unbelievable consumer of carbon. It's 7 times as much carbon being absorbed as existing steel plants emit, which is a gigantic change for the good of the planet.
Thank you.
Perfect. Thank you so much, David. All right, that's all the time we have. But feel free to leave your information in the chat.
I will.
Perfect. Beautiful. Next up, we have Scalvi, and presenting for Scalvi, we have Mohammed. Feel free to start sharing whenever you're ready.
All right. Hi, everyone. Great meeting you. Sharing my screen now.
Yep.
And hopefully you can see it well.
Yeah, we can see it just, yeah, now it's
all right, perfect. All right. So at Scalvi, what we're working on is that we are developing electric powertrains for the electric mobility industry. And we define an electric powertrain as the electronics and the software system from the battery to the motor, agnostic to the battery types, agnostic to the motor types. So what is the problem that we're trying to solve is that currently in the industry, if you are Ford and you're going to one of the tier 1 suppliers to help you with your powertrain needs, it's a process of 2 to 3 years for a single powertrain to be fully developed and tested in your vehicle. And the second problem is the high cost. The high cost that is forcing suppliers to only work with high volume OEMs, meaning 30,000 units plus a year, and only very few OEMs who can reach that volume, leaving a huge portion of the market completely underserved. And then finally, the supply chain complexity. Suddenly, everyone wants to electrify. Everyone is going after the same components, plus the complex integration of the current systems. And so in summary, the current status quo of how we develop electric powertrains, the high level of customization, is not sustainable for the electrification wave that we're in. So what are we doing at Scalvi? So briefly, an electric powertrain has 5 main subsystems: an inverter to run the motor, converter for the DC loads, charger to charge the battery, battery management system, and controller. And conventionally, every one of these subsystems is highly customizable. And then as an OEM, you are the one who have to integrate all of them together. An OEM is basically the EV manufacturer or the electric mobility application manufacturer. So what we're doing here is that we are integrating the functionalities of all of these subsystems and then breaking them down into these small building blocks, so that on top or beside every one of our battery modules, it has its own SIM. We call it SIM for Smart Integrated Modules. And then that enables us that the same technology, customization is out of the window now. I don't need to highly customize my system. The same technology can be used in an electric vehicle case study. It can be used in an electric truck. We even had, we were funded by the Air Force for EVTOL technologies. We're currently working with some customers on electric buses, on high power drones. And that's what we're trying to achieve: building a fully modular, fully scalable electric powertrain technology that is quite agnostic to the battery, to the motor, and even to the application, except for very little customizations to be compliant with the standards. So if we look at a face-to-face comparison between the conventional system in the left and our system on the right, it's clear how much simplification we're able to achieve. And aside from this, we are doing all of that at a discount. So something that when we talk about modularity, about breaking a large system into small components, it's always associated with higher cost. But because of our IP and because of our technology innovation that we had been working on for the past few years, we are able to do that at a lower cost level compared to the industry. And beside what we mentioned, we are saving OEMs 6 to 8 months of integration, because the system here in the left, it doesn't come like this. every supplier is going to supply part of the system. And then as an OEM, I have to integrate all of it together. And that's a nightmare if you ask any OEM. The integration is the hardest part. And then we're able to achieve lighter weight, lower size for several reasons. We're able to achieve lower losses. Our efficiency is an average 50 to 70% higher. And what I love the most is the insensitive pricing model. If you're coming to me with only 100 units a year, we can serve you because I have very little customization that goes into my product compared to the rest of the industry. And we're able to do V2X, vehicle to anything, to house or to load or to anything at much higher efficiency compared to the industry. One thing that we are just scratching the surface of right now is the DoD, the Department of Defense electric mobility applications. As I mentioned, we worked on eVTOLs with the Air Force, and there is electric submarines. There is high push for electrifying off-road vehicles. And we have some early case studies with some of the top off-road vehicle companies that cannot electrify their vehicles using the conventional powertrain technologies. We currently are negotiating 2 joint development agreements with 2 of the probably the largest 3 or 4 electric powertrain tier 1s globally. One of them is based in Canada, the other one is based in Europe, and they want to start a joint development agreement with us so that we can work together on bringing this technology faster to the market. Beside that, we are focusing on the low volume market through early commercialization traction. And we are working on case studies with a large number of low volume OEMs who needs our service with support from Flex. We have an MOU with Flex who are supporting our design and manufacturing needs. And finally, we have won a federal grant from the Air Force. Currently, we have been selected for some other grants, but cannot disclose them as it had not been official yet. That's one of our modules here, and you can see how small it is. That's sitting on top of a battery. So it basically takes maybe 1/10 of the surface area of the battery, goes to our powertrain module. We're not using more space than what is already there because every battery module has a battery management system board. We are just replacing the battery management system board with our board that has much more functionalities and is able to do the same powertrain functionalities at higher efficiency, higher reliability, lower cost, and lower weight. We were able to validate and we're able to validate and demo our system with a large number of OEMs and suppliers, and that's where the traction is coming from. We have 3 patents and filing the 4th one now. We have recently closed the 3 million seed round. There is a chance for a second close in the range of 1.5 to 2 million. Specifically, we are targeting strategic VCs with this. We're not actively fundraising, but if there is a good opportunity, we would entertain it. The thing that we are seeking the most now is collaboration with electric mobility OEMs and tier 1 suppliers towards early samples, case studies, or towards joint development agreements. Happy to provide you with demo videos. You can contact me. That's my email address. You can easily also find me on LinkedIn or just through the contact information on Scalvi's website. Thanks so much and happy to take any questions.
Thank you so much, Mohammed. All right, well, we'll get to the questions in order. All right, Rinat, you're first.
Hi, so thank you, Mohammed. Can you elaborate about the team?
Yeah, so the team, I had been an associate professor, just recently became an associate professor at San Jose State University, and I had been conducting research on modular converters for electric powertrains for 5 or 6 years before starting the company. And then last year, I left my job. I founded the company with my co-founder, who has 7 years of experience at BorgWarner Delphi, which is the largest powertrain company here in the US. And then the rest of the team, we have Josh joined us from Lucid Motors with 4 years of experience. Naeem has 15 years of experience in powertrain design. George here just behind me, he joined us from working on electric trucks firmware. And we have, right, the team now is around 7 to 8 engineers, and we are actively hiring.
I have time for, I believe, one more question, if someone has one. Otherwise, we'll move on. All right, absolutely. So Mohammed, in the meantime, feel free to also leave that in the chat so people can quickly copy and paste it, the contact.
Will do, yeah. Sounds
Yeah.
good.
Perfect. Absolutely. And in that case, we're going to continue onward. Next up, we have presenting for us FastCap. We have both Sharon and Mitch from FastCap on the call.
Hi, everybody. This is Mitch. I'm the CEO for FastCap. And if you give me a moment here, we should be able to see slides. All right.
Yeah.
Awesome.
Yeah.
So FastCap ultracapacitors, quick definition or description. Ultracapacitors are energy storage devices. And in this space, you may hear them referred to as supercapacitors, sometimes hybrid capacitors. There's a bunch of different terminology, EDLCs. We operate in all those different technologies, but we chose to use ultracapacitor as the description. So basically a little timeline. All of these technologies come out of our labs. The high-level operating company is Nanoramic Labs. FastCap was the first one. The second one was Thermexit, was a thermal interface material, and we sold that off to Henkel last year. And the most recent one is Neocarbonics on our lithium-ion batteries. And since 2019, that's really where the majority of the focus and energy has gone into from the labs. But we realized that there was a lot of value and a lot of profitability left in the ultracapacitor business. So here in 2023, we're going to spin out FastCap as a new entity. It's kind of a restart with a fresh face, new capitalization, all those kinds of things. Also, a quick note, since we have Renat on, we do have investment from GM Ventures in the battery side here on the lithium battery side of our business. But before we kind of put FastCap in mothballs and went to focus on batteries, we had quite a bit of success. We had funding through some major companies, Halliburton and GK, and we also had more than $10 million in grants awarded to develop the technology that we work on. Some of the industry pain points, I don't have time to touch on all of these, but you'll see me compare us to rechargeable batteries or to capacitors in most cases, because those are the other energy storage devices we typically compete against. And rechargeable batteries don't work well or don't work at all at cold temperatures or high temperatures. FastCaps do. The cycle life is much, much greater with FastCap than it is with any rechargeable battery technology we're aware of. And then safety. FastCap is very safe compared to a lithium-ion battery. If we had more time, we could get into some of these other pain points, but I know we need to move on. So from a product portfolio standpoint, we've developed a series of products at FastCap. I'll touch briefly on two of them. We have the one here in the center, which is the high temperature ultracapacitor. We call that Delta. This goes back to the comment I made about Halliburton. Halliburton paid us to work and develop some technology for them. They liked it so well, they ended up investing in the company before we went into kind of the mothball stage. So that was a great product for us, still is. And we've also developed a low temperature product we call Lima. This was developed for high altitude, very cold temperature. It's currently being designed into an electronics package that's on the skin of the aircraft. And their original design thought was to use 4 AA batteries plus a heater blanket, plus a control system for the heater blanket. Because we work so well at -55, -60, they were able to replace all that with one of our AA ultra caps. So with our background and some of the previous time in the industry, We've been able to develop a really great patent portfolio in addition to trade secrets and know-how. The reason we wanted to restart this is because the market's big. It's not as big as the battery market that we decided to focus on out of the other group. But when you start looking at 2030 and beyond, between the ultracapacitor market, the cannibalization that we can do in military batteries and the capacitor market, we're looking at over a $30 billion opportunity. And real quickly to mention one other application, medical devices. We're working with a medical device company that makes a handheld surgical tool. They can't use batteries in it because they want to use thermal sterilization. And thermal sterilization goes to 130C. Batteries don't typically survive that, but of course our fast caps do that quite well. With the market size as expected, there's a lot of key market players. I just copied this list from a recent market report from Supercapacitors Market. And you can see some really big names on here, some other medium and small size companies. But what I was very happy to see is that even with virtually no outreach going on in the last 3 to 4 years, they still recognized FastCap for some of the technology innovation and some of the market presence that we've had. So again, why are we doing this? Why are we going back and creating a separate company? We want to create value, and to do that, we've got multiple paths to revenue. We've licensed our technology in the past. We could go ahead and do that again. We're currently doing some production in-house. We can scale that up. We can go to contract manufacturing. As we did with the Thermexit technology I mentioned earlier, we could sell a portion of this technology off, and we can sell the entire business. It's a great position to be in as far as having all these different opportunities.
30-second warning.
Okay, great. Thank you. So what are we looking for? We're looking for basically 3 different areas. Investments, because since this is a restart, we are looking at recapitalizing this. We have a couple of seed investors. We'll probably be looking at a Series A end of this year, beginning of next year. So we'd like to be speaking with any of you that are interested. Anybody that's interested in licensing our technology to generate more profits or more revenue. And then customers. Hopefully we can improve your product. We'd like to talk. We can reduce product cost in a lot of cases, and we can reduce or eliminate some dependence on batteries that you may have. Got a nice picture of the folks that are working the core team at the FastCap side. And then we've got our support team, which is coming from the Nanoramic Labs side. And I think I got in under 5 minutes.
Awesome. Thank you so much, Mitch. I'll open the floor up for questions. So feel free to start raising your hands. All right, John, go right ahead.
Yeah, so I thought the medical device example was really interesting, as it was a case of sort of a new opportunity being enabled by the technology. Can you elaborate? Are there other sort of examples of that in particular, where it's new opportunities that are available that wouldn't be otherwise without this technology?
Sure. The medical device is one of the primary ones. I touched briefly on something when I was talking about the high temperature application and Halliburton downhole. So I think we're going to be moving in certain energy production into geothermal types of wells and large geothermal. And to do that kind of drilling is very, very high temperature. We've created some prototype ultra caps up to 300C. That was under one of the prior contracts we had with NASA. So we can get into something like that where they didn't have the capability of running a high temperature rechargeable energy storage device downhole.
Great, thank you.
Yep. And there's probably some other consumer devices and different things that one that we're working on that I can't talk about. It's proprietary, but if you have more interest, we can get a non-disclosure, John, and I can give you a little bit more detail on a consumer device. Yeah.
All right, Diana, you're up.
Diana, one.
Hi, Mitch. Yeah,
Hi.
I'm with NOV. We're Halliburton's largest component supplier.
Yes.
I don't know if you're aware. Can you tell me a little bit more about the number of cycles that the ultra caps can handle? And the reason that I ask is for geothermal drilling activities where we're heavily invested.
Yeah, no, understood. Yes, you and I were probably used to be neighbors. I used to live in Sugar Land. So know the industry reasonably well. But yes, so the cycle life is really going to depend on a couple things. It's going to depend on the temperature, the time at the temperature, and then the voltage that we're running through the system. So it's hard for me to give you an exact answer on cycle life, but typically what we've seen, even in very high temperature applications, is we've been able to generate hundreds of cycles, even in those real abusive conditions.
Okay.
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 And if you want to dig into details, we can chat offline.
Yeah, I'll shoot you an email. Thank you.
That'd be great. Thank you.
All right, perfect. Thank you so much, Mitch. With that, we're finishing off the first session, and we're going to start with the second session. And the first company of the second, anyone who's in the first session who wants to stay on, feel free. Anyone who's on for the second session, welcome. Happy to have you. We're going to start, because we're running a little short on time, we're going to skip the panel introduction. So please just introduce yourself once you have a question, if possible. And we're going to get going. The first presentation we have for the second session is Jaker Tech with Mark Jaker presenting. So Mark, the floor is yours. Let me just, Mark, do you want to share it on your end, or do you want me to?
Go ahead.
Okay. Give me 1 second here then, because I think it was everyone bear with me. This time is on me, everyone. But it should be up now. Okay.
Okay, I don't see how I can change the slides.
Yeah. It's going to come up. Give it a second. It's still loading.
All right.
Okay. Now, let's go ahead and add slide control. All right, can you see it and change slides?
Yep.
Okay, go right ahead. Get started.
All right, real good. Thanks. I'm Mark of Jaker Tech. We started thinking that batteries did not need wet electrolyte. If you could mix actives in a binder resin and still get ionic conduction, you could injection mold dry cells faster, no solvent drying time. So it turns out to be true. And now they're called solid state batteries. Let's see. This is not a straight, simple path. First hurdle for us was not how to make solid state, but what recipe to make. We needed to find a demonstrated chemistry, and then everything else would fall in place. The idea is to use existing injection molding facilities anywhere in the world. There are tens of thousands that have a certain level of technical savvy and discipline, like ISO, ITAR, 13485, and automotive suppliers. The business model idea being somewhat akin to Uber or Airbnb. The facilities already exist. Almost all are job shops, and they're always looking for work. It's almost a plug and play concept, with some processing nuances, of course, for battery materials. You do not need a dedicated battery facility, let alone a gigafactory. Our manufacturing footprint is ridiculously compact by comparison. Just the idea of using existing resources is greener. Our partner is Purdue University. They have a superb chemistry department, the Viper Group, headed by the infamous Dr. Vilas Pohl. Our first chemistry is a lithium metal solid state battery, currently with about 350 watt-hour per kilo, that is firstly super safe with no solvent, long cycling with huge operating temperature ranges, -40 to +330 C. It's flexible, tested, validated, published 2 times in Elsevier, and ready to go. It turns out that Purdue is one of the best electrochemistry schools in the world currently. So while lithium-ion batteries are sort of the me too chemistry today, lithium metal goes farther up the ladder. Next, we are looking at other recipes like lithium sulfur, sulfur selenium, and these are in the 450 to 600 watt-hour per kilo range, with theoretical potential several times that in some cases. Keep in mind that Tesla's 18650 lithium-ion cells are 272. So no matter how you cut it, we're beyond that. Lithium metal will get us to electric aircraft, but lithium sulfur or sulfur selenium, for example, make NASA's dream even more real. Once again, it's safe with no solvent, yet much higher energy. Reliable, high cycle life, and tough. There are other chemistries potentially applicable to this more economical manufacturing method, and we are and have been exploring those as well. All right. So in addition to our near-term offerings, we intend to offer other chemistries in the future. We are not a one-trick pony like our competitors. We are a manufacturing technology, and we are a logical manufacturing evolution. Our packs will be sort of like a big printed circuit board or huge chips with integrated current collectors, wiring, and components. Plus, like chips, we can do multi-layer stacks, saving space, weight, and assembly time. This is similar to how many simpler electronic components are made today, which I have considerable experience. Connectors, plugs, capacitors, transistors, switches. Just go to your local hardware store. So to recap, this is a technological advancement. We gain speed while simultaneously producing higher performance with interfacial fusion, all because of solid state. Unsurpassed interface with heat and pressure, so no dendrites. It's the safest chemistry going. Safer steps, fewer components, lower weight, lower costs. No separators, no steel, no welding, no post-assembly steps. Injection molding has the lowest CapEx and therefore the fastest ROI, and we can manufacture almost anywhere in the world, excluding North and South Pole, I'm pretty sure. No site location, search, factory layout, sewer, water, construction permits, electrical supply lines, roads, rail siding, greasing local authorities. None of that. It's already there. Tougher with an elastomeric fluoropolymer electrolyte. Huge temperature range. Some call these space batteries, certainly aerospace. And we can do conformal geometries, just like any plastic part you can think of. And it's patented. US, China, India, and about to issue in Europe. If you have any questions, thank you for your time. Get in touch.
Thank you so much, Mark. All right, so again, Matt, you're the first one to raise your hand. Go for it.
Awesome. Thank you so much for that. So my question is really kind of on, I want to understand the manufacturability of this. So even if you're doing injection molding in a dry state, you know, there's still the aspect of having to either develop your own end-to-end manufacturing line or either work with a contract manufacturer and have it be integratable. So can you kind of walk me through what equipment you actually have and what processes you need? And then what do you actually hope to own in the manufacturing line?
All right, so I've been in the business for almost a half a century. I'm a seasoned fellow. There are 4,000 injection molders in the United States. Probably 25–30% of those are of the category and the system level that could do this kind of work. They have closed loop systems. They have all the equipment in place, and we're talking about utilizing basically plug and play. There are modifications that need to be accomplished around the platen area, the actual work cell area of the injection molding machine. The platen are the two plates that move back and forth and hold the molds in place, right? Those need to be dry. So that's different. They're accustomed to dry material processing, of course, for engineering resins like nylon and such, which have to be below 1% humidity content, or you're making junk. But we're talking with lithium, it's susceptible immediately to oxygen and humidity reactions. So we're going to contain that environment. That's a minor thing. Certainly, we can process in a dry room around that machine, but we're talking about a very small footprint. They already have pick and place robotic cells to load and unload. We're talking about taking anodes and cathodes and basically squishing the two and creating a sandwich with solid state electrolyte in between. And there's no drying time. So everything, instead of being minutes or hours, is seconds. And I mean just a couple seconds. Injection molding is very fast. Makes a lot of stuff real fast. The world, we have a bad name globally, but you should, and people are chasing us around all the time. And sometimes it's justified and a lot of it's not. It's just ignorance. But yeah.
All right, Lisa, you're up.
Hi, Lisa Dufresne, GC Ventures. So, we've seen a lot of technologies coming through for battery recycling. So what does end of life look like for the batteries that you want to make? More recyclable, less recyclable, what?
My family happens to be the #1 recycling manufacturer of equipment and installation of facilities in the western part of the United States, H-West Equipment. These are both thermal and chemically and thermally and mechanically recyclable. You can turn it into black mass and you're back like everybody else. I belong to NatBat and I'm a member of Military Power Source Consortium. This is a topic that's ongoing and of considerable interest. And we fall right into it very, very easily. So it's no different than lithium ion from that perspective, except that you haven't got the problem of explosions. When you throw lithium ion batteries into a grinder, which is going to chop things up, it can be a very bad situation. You're going to have fires, explosions, people can get hurt. You can't throw it in the common waste stream. It's got to be separated from that perspective. Lithium metal is probably not going to have that same explosion characteristic. It just doesn't. And part of that is the solvent. There's nothing to ignite. Lithium metal by itself can be explosive in water. So you have a dry environment requirement, sort of. But beyond that, it's straightforward.
Perfect. Perfect. Thank you so much, Mark. Mark, make sure to leave your contact information in the chat, because I'm sure there's some folks that are interested, and we appreciate the presentation. Next up, we have Polam.
Hello, I'm sharing my screen.
Yep, go for it.
All right, so it's Coulomb technology. And my name is Tim Vosberg. I am the founder and CEO of Coulomb Technology. We are also working on batteries. So we're working on new and improved batteries, which I will tell you about. We have a disclaimer. Some of this is forward-looking. So we set out to improve batteries because there's so many issues with the current technologies that exist today. And we've licensed and are manufacturing a zinc ion chemistry that does just that. So as you know, global warming is huge, causing many issues. Batteries are a great part of the solution, but many of the current batteries use rare earth materials, are very expensive, have safety issues, or poor performance. So our batteries are different. So we've spent about 10 months. We paid a large team of researchers. We met with most of the prominent university battery experts, and we looked at 82 different chemistries. So after all that research, it led us to this zinc ion chemistry that is available from UCF. So now we have licensed and are scaling up this chemistry that has been in development for about 8 years. And it was produced by Professor Yang. And it's a zinc ion material that is a zinc anode and an Mn cathode with a seawater electrolyte. So what that means, it's very safe. So we have a much safer battery. We don't use rare earth materials. We are very recyclable. We have very, very good performance today, including high power, fast charging, high density, and great thermal performance. And we're about half the price of current LFP batteries, maybe even better than that once we get to scale. So the market that we're looking at, so we can play in all 4 of these markets. So grid storage, residential, e-bikes, and backup power. Even grid storage, we're looking to do between 4 and 24 hour, where there's a huge gap today. But since our batteries perform super well today in the backup power because we have very fast charging and very high power, that's what our current focus is for our first product. And where are we at in terms of development? So batteries typically take 8 years to get from concept to production. So this chemistry has been in development for a long time, since about 2012. So currently we're here in the middle at TRL4, and we're making our first pouch cells today, and then plan to get to TRL5 in the middle of 2024, and then 7 and 8 about 2025. Current traction. So we got quite a bit of stuff in place. So we have a lot of proven coin cell technology. We're making a few pouch cells now. Those should be done in about a month. We expect some good results from those pouch cells. We have a lot of customers waiting to test those pouch cells, and some have signed LOIs. We're part of the Santa Clara incubator. We have several follow-on and some investors waiting for pouch cell data. And then we are talking with many of the universities and national labs to do some optimization work with us. Some of those are funded by the DOE, and we're applying to grants together as a team, including a grant that I'm working with my competitor on to solve a common industry problem. We're also awarded a TA program for a grant called 40209. 40209 is to build a factory in a former coal community. So we're looking at doing that. So potential issues, typical common battery issues are dendrites, corrosion, etc. We think based on our coin cells, we won't have issues, but there are companies that we are talking to that have solutions that we will test if we need to. Our TAM is huge, as you know, for batteries. We whittled our SOM, our available market, down to 360 million. Top-down approach, and our bottoms-up approach, if we fill our factory, which we think we can do with a few customers, would be about $240 million with a 5 gigawatt factory. So we don't expect a lot of issues filling our factory and meeting our TAM. We're raising money, so we're looking for 1.2 million with about we're flexible on the valuation, but our goal is to have an $8 million post. And this money would be for sale optimization and finishing our pouch cells that we're working on, and some supply chain work. We have a huge team. I have a background in setting up huge volume manufacturing lines for Apple and Flex, as well as semiconductor equipment. And we have several other battery experts, including somebody from Natron, somebody from 24M, somebody that used to be at Tesla, and a guy at Qbird. So most of these are PhD chemists. And then we have advisors. So Professor Yang is the developer of this technology. He's thinking of being a co-founder, but he'd have to leave his tenured position. He's a very integral part of our company. And so that's my last slide. So in summary, we have proven patent pending technology, a lot of advantages. We are partnering on lots of grants with many of the national labs, including our industry. We will do onshoring and working with the DOE on a program. The market's enormous. We have LOIs in place to test when we're done. Part of the Santa Clara program, and many follow-on investors and even maybe leads are interested once we get our pouch cells done, which should be about a month and a half from now. And then we just need to scale, and we're experts at scaling. That's what I've done for the past 25 years. So that's all.
Perfect. Perfect. Thank you so much, Tim. All right. Feel free to, yep, Lisa, go right ahead. Love it.
Got stuck. Hi, Tim. Good to see you. So I have a question about batteries in general. I think about a car battery, they're all kind of the same. I can buy anybody's battery, stick it in my car. When I think about my electric tools at home, every single one is different. So when you design a new battery for the markets that you've described, are they drop into anybody's battery system? Or is every manufacturer of a new battery going to be a different size, a different shape, need a different way to charge, sort of like my little hand trimmers at home versus the way that cars are today?
Yeah, so with each of those use cases, there will be more or less drop-in, but you can't cross-platform them. Like you can't take a battery that's good for fast charging or for lawnmowers and then use a similar type battery for energy storage. They're all designed with different parameters. Like one will charge better over longer term, one will have different voltage. So there will be some differences, and then you'll also have to have a different BMS system. So for lithium, there's quite a few companies that you can outsource and have a BMS developed for you. For zinc, it's we may need to do that ourselves actually. So that is one issue, is we'll probably have to develop our own BMS, which is the management system that these batteries go into, because a lot of those integrators are focused on lithium because there's just a lot of interest there. So we are working to set that up as well. We know that we'll have to do some work in making it cross-platform and as agnostic as we can, but we will have to develop probably our own integration work. That's what our competitor does today.
Perfect. All right, Tito, you're up.
Yeah, thanks, Tim. Just on the scale-up side, as you said, after the pouch proof successful, are you thinking to fully outsource scale-up? Could you talk a little bit more about what unit operations this would require? And a lot of battery processes and material development breaks as you try to bring it up, as you probably seen through, it's the same things to develop things in a lab. How can you mitigate a little bit of those risks?
Very good questions. So we did look into this a lot, and we are talking with partners to potentially build a factory, such as Jeff Wilkes, former Amazon guy that set up a company called Rebuild to bring jobs and manufacturing back to the US. So he's interested in doing a factory with us. There's not a whole lot of outsourced contract manufacturing for batteries, just because the volume is so big. There's everybody that's already doing something like Core Power. American Battery Factory is too busy. We've asked them, and they said, well, we're too busy to build your batteries. So, and because that's what I've done for 20 years is help scale up technologies. That's what we plan to do in the US. And we're getting our hand held a little bit right now by the DOE. So we've been awarded a grant program to help build a factory in a former coal community. And they're doing some work with us to do that. But you're right, the scaling is a large problem. We're taking that carefully and working with a lot of partners to make sure that goes very smooth.
Can I do a quick follow-up?
Go for it.
Are you presumably trying to scale up both the material manufacturing as well as the cell assembly for this material, or you're gonna plan to sell it as a chem?
We'll make both the electrode, if that's what you mean, and the cell. So we'll do both. So we have actually a patented electrode manufacturing process. So we're using electroplating. So we're electroplating a zinc copper alloy onto a zinc foil. And that's something that's part of our IP, is how to do that and then how to get a 3D structure out of that. So we bubble hydrogen to help make it 3D. So that's been scaled up once by Professor Yang, and we're going to do it again for this specific chemistry. And the raw material, though, is quite a bit of it is this. So it's zinc. Zinc is a very common battery material today. It's in a lot of your little AA's and AAA's. So zinc is super common. And the rest of the material is pretty cheap and common too.
Cool. Thank you.
You're welcome.
All right. Perfect. I think that's the time. Thank you so much, Tim. Feel free to leave your information in the chat. I know that there's a few folks here that there is some interest. So go right ahead and do that. Next up, we have Intergalactic. Feel free to start sharing your screen whenever you're ready, Nick. Good to see you.
Hey, Asher.
Hey.
Can you see that all right?
Yeah, we see it perfectly. Company and capabilities.
Great. Hi, everyone. Thanks for your time today. My name is Nick Kaiser. I'm the Chief Technology Officer with Intergalactic. And I'll jump right in. We're really a very heavily aerospace focused company doing thermal management work. My main interest today presenting to this crowd is really to kind of see what kind of alignment there might be with our technology and things we have to offer with the energy sector. I'll get into a little bit more. We do some energy related work in particular segments of aerospace, but not really a whole lot with the energy industry directly. But a little bit of history about the company. We're about 7 years old. We were formed really to solve some of the emerging problems in thermal management in aerospace. There's kind of this intersection of increasing thermal problems, but really a almost complete lack of any kind of innovation or technology development over the past several decades. And that's resulted in a constraining problem on a number of platforms, whether it be new electric flight platforms, high performance aircraft, space, really you name it. There's just always a desire to pack more high performance electronics and heat generating stuff into small places. Like I mentioned, we've really gotten our start primarily in aviation, especially defense aviation. So high performance applications on things like fighter jets, new emerging high power electronics, things like that, going into places like that. But we have kind of worked all over the place. We've done some undersea work, some ground-based systems, some stuff going up into some of the new space stuff, particularly lunar applications, lunar space stations, stuff like that. Really anywhere where there is some kind of heat load and a desire to be as small, lightweight, and power efficient as possible. And I think that that might be where there is some good potential for use in energy applications, where there's tremendous heat load sometimes, and efficiency gains can really bring about a lot of benefits. kind of an overview of some of the equipment we offer. We're really a systems company. So we make a lot of thermal management systems for various platforms, whether it's air conditioning for an aircraft, or cooling or heating or holding some piece of precision avionics at a very particular temperature over a wide range of conditions and extreme environments that you find in an aircraft or a spacecraft. We do all the systems engineering, a lot of the constituent components that go into these systems we develop and build as well. But the whole focus has been on developing new technologies and integrating them into the systems, along with a focus on system engineering and optimization. And one of the key pieces of technology that really got us off the ground is what's called a microtube heat exchanger. And really what this is a heat exchanger that's very small, very lightweight, with low pressure drop compared to the existing technology that's out there. And it's actually kind of funny. The one thing we found in the energy space is applying this technology into a cryogenic system for long distance, high power transmission using liquid nitrogen. So it's kind of a specialty case and a unique technology, but that is the one spot we've found some work in the energy space specifically. Like I mentioned, a lot of systems work, what I'll call traditional vapor cycle systems, although heavily modified for and optimized for maximum efficiency, minimized size and weight, things like that. Advanced materials, intelligent software, things that are very applicable to aerospace. But really, again, the whole goal is to keep these things as small, light, and efficient as possible. More recently, we've been really getting into the electric flight space. So it's been interesting to hear a lot of battery companies here. I think it sounds like a lot of stuff for ground-based vehicles, but we have been working on thermal management systems specific for electric flight, where we're trying to keep batteries on aircraft conditioned both during charging and also during operation, along with all the regular thermal management you find on an aircraft. Like I mentioned before, at our heart, we're really a systems engineering company. We've heavily embraced model-based design and optimization. That really enables us to both get every ounce of efficiency out of our systems that we can, but also collaborate closely with our customers during development. Quick snapshot of our team. Again, aerospace company. A lot of our leaders come from big primes in aerospace, myself included. Really, my whole career and background is in aerospace thermal management specifically. We kind of have folks from all over the place: space, defense, commercial aviation, the whole gamut. And like I mentioned in the beginning, really what I'm looking for here today is just if there could be, potential need for more efficient, smaller thermal management out in the energy space. It's an area that we're not as familiar with. I mean, we have connections and we hear things. I think there definitely could be some overlap, but initially here, just kind of wanted to give a really high level overview of what we do and then see if there's any questions. That's my super fast pitch, and certainly happy to field any questions and see if there's anything out there.
Perfect. Thank you so much, Nick. So we'll open the floor now. Yeah, Lisa, go right ahead.
Hi, Nick. So, the kinds of, I work for a petroleum refinery, but some of the applications that you talked about look like they're sort of high end and maybe willing to pay a premium. So when you think of new applications, do they have to be ones where someone's willing to pay a premium for the kind of product that you're delivering?
Yeah, that's a great question. So historically, yes, we started out in defense aviation where they're really, you're looking for absolute peak performance, new technologies and things like that. But more recently, we've been working hard to get into commercial aviation that's much more cost sensitive. And I think, that's put us in a position where we probably could jump into supporting more industrial applications where there is much more of a focus on cost.
We have time for one more question. Otherwise, I might jump in and ask one.
Yeah, sorry, I cannot figure out how to raise my hand on this thing.
No worries.
A quick question. So for reference, my background is space industry, so excited to hear some of what you're doing. I'm curious from that perspective how you're dealing with some of the radiation that's less of a problem on like Earth-based systems and how you're making this ubiquitous across both sort of space applications and terrestrial applications.
Yeah, that is definitely a challenge of going into space. And really, like, that's kind of taking a lot of our, especially on the electronics side, taking a lot of our equipment and hardening it for those environments, particularly when we're going out to like lunar stuff. Radiation's up on another level there. But a lot of that is kind of a mixture of, I guess, traditional hardening for radiation through materials, but there's also some new like composite materials that we're looking at that are pretty good at radiation protection.
Okay, thank you.
Yeah.
Perfect. Perfect. I think that's the time, but thank you so much, Nick, for the presentation. And feel free to leave your information. As always, it's a pleasure to have you. Next up, we have Will Marshall with Kelvin.
Howdy, everybody. Nice to meet y'all. Looks like we're running a little bit behind time today.
Yep, a little bit.
I blame Asher primarily for that one.
It's my fault.
Just giving you a hard time, Asher. Hi, everybody. My name is Will Marshall, VP of Finance here at Kelvin. Kelvin is a software company that helps our customers make AI-driven control decisions at scale anywhere in the world. I'm going to be giving just a quick 1 to 2 minute intro into it, and then I've got my head of product on the call, Rohan, and he's going to give a little bit of a demo. Well, we are 65 FTEs, SaaS company, like I said, headquartered out of Houston, funded by VCs and SF, and distributed remotely across the globe. We have SMEs, subject matter experts in upstream oil and gas, large language models, and scaling applications across the enterprise. We're focused on streamlining workflows for production engineers and software developers to demonstrate applications that are optimizing assets in the field, primarily wells or frac fans in North America. And we're looking for non-dilutive funding and also an audience of production engineers for feedback on the tool that we'll be demoing for you today. We are not actively fundraising, but we're opportunistic with strategic partners. And we're also not a data science shop, but we partner with expertise in data science. And we're also not in the market for new engineering resources. So I know that is a component of for some people come in here who are looking to bring value to the marketplace, but we're not looking for engineering resources. We're also not a hardware manufacturer, but we do connect to sensors that sit on distributed assets. Kelvin at a glance, we've raised 40 million to date. We have 8.3 million of ARR as of today. And across our lifetime, about 8 to 10 years, we've delivered over $100 million of economic impact to our clients. We are currently connected to 1,000 wells and frac fans, both in Australia and North America. And we've helped deliver over 50% reduction in the methane emissions on those connected vans. What do we do? Our software allows engineers to get insights, take actions, and deliver impact to their business. And we enable them to make smarter control decisions that improve profitability and achieve their sustainability goals. So a little bit of a flavor of our customers, as you can see, primarily upstream oil and gas, and midstream and oil field services. So what are our problems that our customers face? The equipment that they're trying to manage is distributed across large geographical areas, making it very difficult to manage. The software applications are not able to easily take actions on the distributed assets. We need incomplete automation, which also leads to unsustainable digital transformation. Our production engineers lack tools to automate that domain expertise and custom workflows, leading to more inefficiencies. That's where we come in. But what is Kelvin looking for? We're looking for new customers and opportunities for feedback on our AI tool that we'll be demoing for you today. We're calling it Project Phoenix internally. Our problem, Kelvin's problem, primarily in the go-to-market motion, is our sales cycles can be upwards of 12 months from a EULA agreement to a pilot to enterprise, and we're looking to shorten that sales cycle. Our hypothesis is that this AI tool that we're going to demonstrate for you today can be a wedge into that to help shorten that sales cycle. All right, with that, I'm going to turn it over to Rohan. And Rohan, the floor is yours, my man.
Thank you very much, Will. I'll run through a quick demo in the interest of time. And as Will said, the challenge that we're trying to solve here is, there's a lot of information that production engineers are have to go through in order to make decisions on how to optimize their wells or change things in their operation. And they're typically dealing with a lot of different variety of data, whether it's structured data or unstructured data. And that's the initial problem that we're trying to solve here, to get them into a crawl, walk, run phase where they can get these insights, automate some of that, and take that and put it into a larger application that can then be continuously automated and run in an autonomous mode. So some examples here of the type of questions that one could ask, right? And if you look at this screen, there are some data sources that we have linked here. I have uploaded a bunch of documents over here, but these sources can also be data sources that are live and online and that we can connect and integrate to. It could be a data warehouse, it could be a SharePoint folder, it could be any of the operations tools that production engineers work with. So I'm going to start, I'm going to ask a few different questions of different sources. So for example, one of the problems that customers face is identifying what are the terms of a lease, if they are leasing land or lease wells from other companies, and how do they plan their operations based on what those conditions are. So one way for them is to go look at, go open a bunch of lease documents, read through them like pages and pages, or look at, those specific conditions, extract them out, and then take them and give it to, someone who's going to plan their operations. The other way is to basically ask a simple question saying, what is the condition of the royalty payment on a particular lease? And this tool basically, pulls those conditions out from across the document, sort of summarizes it in a way that's very easy to understand, and it also shows you what is the source of the document and what pages exactly it pulled that information out from. So you can imagine that if there are like 50 different wells, it could have 50 different leases, and if we want to aggregate all the conditions, you have to go through each one of them and do that manually, and there's no other way to do that today. So we are utilizing generative AI and large language models at the back as technology to get this information out. But what we are really doing here, which differentiates us in the market, is building that the ability to ask the questions and translate this information in a way that it's very specific to the oil and gas domain, to the production engineering domain, and potentially this could be extrapolated out to other engineering domains in the manufacturing space. I can ask another question of a different data source. So for example, I asked about like what is the royalty payments on this lease, but I may have a question around something which is more operational in terms of what are the perforations on a given well. And these details are used together in trying to understand, if I have a well of a certain sort, and if I have to recommend some kind of treatment on that, what is the impact going to be on the production, and based on that production, how do we then link it back to the lease and how much royalty we are going to pay, and those sort of things. So again, here you can see that
warning. Just we should 30 seconds.
Yeah. So just so to summarize what we are showing here, again, like we have fine-tuned the way we ask the question to extract information out of these sources so that it gives you exactly the kind of information that a production engineer would be looking for, and in the format that they would be looking for, but also show the source from where we got it. So just to summarize, right, we are trying to solve the problem here of how do we accelerate finding that the insights from a large variety of data sets, from a large variety of documents and data sources, so that someone could take this, automate their own workflows, and then basically scale that up to be an application that runs more autonomously. So I'll stop there.
Perfect. Awesome, Rohan. All right, questions. Opening up the floor. If not, I have a few. Okay, Lisa, go right ahead.
So, I mean, did I miss something early on? You said something about being able to reduce CO2 emissions at a well. I've seen lots of software that, claims to be able to look through documents and pull out information sort of more easily in the way that you describe. But how does it actually help a well operator reduce their CO2?
That's a great question. So in order to, I think reducing CO2 or reducing carbon out of operation is an outcome of how you run the operation itself. So maybe your equipment is at a stage where it has degraded to a point where it's emitting more carbon, and you just have not caught that condition. That could be a reason why you're emitting more carbon in that particular operation. Or it could be that the quality of the material that you're processing has changed, your process has changed, and you need to calibrate the operation based on what has changed in order to reduce the emissions. Those are some of the levers that you can pull in order to determine where it is emitting from and what you can do in order to reduce those emissions. I was demonstrating to you more from the perspective of an upstream scenario in terms of optimizing wells, but you can apply the same thing to this situation where you need to now fine tune the operation of that particular equipment. And in order to understand that, you would need to go read up through standard operating procedures, what maintenance has been done in the past, what is the current operation ongoing, and what is the sensor reading from the different sensors on that particular equipment, and how you can fine tune it. You may want to gather all that data. These are all sitting in different data sources. They're not in one place. You want to gather that data first of all, and you may want to trigger some sort of a simulation in your simulation tool in order to see if you go and reduce the speed by 50 RPM for this equipment, is it going to address that particular failure or that particular run mode, and is it going to emit less? Those are the correlations that you can start making and sort of code in that workflow in here.
Perfect. You're up.
Yes, so this is a great tool as long as you have a reliable and organized or somewhat organized data source to take from. Is that part of Kelvin's sort of integration process with the customer to help them create the right data frame and data pipeline for them to actually access not only documents but real life sensor data from the wells?
Yeah, absolutely. What I did not show here is the rest of our software, which would take a lot more time, but there's a strong foundational platform underneath this, which has all the elements of being able to connect and pull data out, organize the data, actually contextualize it based on like what equipments are related, where is material flowing, what's the process, and so on and so forth, and ultimately related to the impact KPI that you're trying to track. You have a great question in terms of like, do you need all the data to be organized? I think it depends on the situation. What we're trying to do here is actually marry unstructured and structured data. Structured data, we can shape it and organize it and contextualize it in the way that you were mentioning. Unstructured data is a little more difficult, but with the availability of things like large language models, we are able to do more with unstructured data. And specifically because we are fine-tuning it to oil and gas right now, but to other domains in the future, it allows you to pull out that specific information from the unstructured data and take it to the structured data, which we have already contextualized in our platform, and marry them together.
Thank you.
All right. Perfect. Thank you so much, Rohan and Will. We really appreciate the presentation, and I definitely enjoyed the live demo. Feel free to leave your information in the chat. And so if anyone who would like to get, some more info or, just chat is able to. And yeah, we definitely appreciate it. Next up, we have Valgotech. Feel free to start sharing your screen whenever you're ready.
Hello, just give me a moment so I can share the screen. Screen. go to the presentation mode. Hello, everyone. Is the voice clear?
Yeah, it's clear, and we can see your presentation.
Okay, great. Thank you. So again, my name is David Olawale. I'm the president and founder of Vargotech. And at Vargotech, we are developing advanced lithium sulfur batteries for different applications like aircraft and unmanned vehicles. So capabilities cover three key areas. One is ultra-low temperature batteries, and I'm going to be talking more about that. We are also into lithium metal batteries, in which we are focusing on lithium sulfur and chemistry, and then we're also working on solid-state batteries for electric vehicles. So we all know that most of our battery applications for different systems make use of lithium-ion batteries. And with lithium-ion batteries, there are a number of challenges and problems associated with that. One is the thermal runaway. So many of us are familiar with lithium-ion batteries catching fires in vehicles, on the plane, and even cell phones. The other thing is that lithium-ion batteries, in terms of the energy density, talking about the weight, that's reached its limit. And that's why those batteries are quite heavy. The other issue with lithium-ion batteries is that the electrode are made of foreign source and expensive materials like nickel, cobalt, and manganese. And we know that China actually controls the supply chain for those materials. And this poses great security risks to the United States. And so our solution is to develop the lithium sulfur battery chemistry. And why lithium sulfur? The reason is this. One, when it comes to the theoretical energy density, the theoretical energy density of lithium sulfur battery chemistry is 2600 watt-hour per kilogram. Compare that to 570 watt-hour per kilogram for lithium-ion batteries. So there's a lot of potential to actually reduce the weight of the batteries with lithium sulfur. The other thing is that lithium sulfur battery is safer, and that is because of the formation of a passive layer on the anode, and that helps to reduce the occurrence of fire outbreaks. And finally, with lithium sulfur batteries, we are replacing the cathode using materials like carbon and sulfur that are readily available and abundant in place of the expensive nickel, manganese, and cobalt. Now, to put this in perspective, when you look at the cost of 1 ton of cobalt is about $75,000, while the cost of 1 ton of sulfur is less than $400. Now, the application of lithium sulfur battery is quite wide. Anything that requires lightweight batteries, the lithium sulfur battery is good. So, satellite applications, modern munitions, unmanned air vehicles and systems like drones. And also, when we talk about our airmen and soldiers, they are required to carry enough batteries to power their electronic devices for 72 hours. Many of the veterans that we've spoken to, they all suffer from spinal cord injury just from the weight of carrying those batteries. And this is data directly from NASA. And you can see that the best battery out there is about $153. With our technology, we want to exceed $200. And currently we're at $151. I'm going to show you later on. Now, apart from that, one of the key strengths of our technology is a wide operating temperature range. And you can see a lithium ion, you can't even get to 0 degrees Celsius. The battery start working. But I'm going to show you, we have done tests with our lithium sulfur batteries. They're able to operate to as low as -25 degrees Celsius and even as high as 60 degrees Celsius. The other thing is that our technology is made in the USA, and we just filed a patent for a new manufacturing process that does not use any solvent like is currently used in the industry. And here you can see how we've grown in increasing the energy density. As I mentioned, we are currently at 151 watt-hour per kilogram, and moving towards a 200 watt-hour per kilogram energy density. So I talked about the game-changing technology, the dry process. So currently in battery manufacturing, they use a solvent, which is called the NMP. They call it the wet process. This solvent is very toxic. It's so toxic that you can't release it to the atmosphere. It has to be captured and then reused. This increases the complexity and the cost of battery manufacturing. Now we have developed a process in which it eliminates the use of that solvent. And because of that, we're able to reduce the time of electro manufacturing from about 16 hours to 1 hour, which is really, really huge. It's a game-changing technology that will make self-manufacturing in the US economically competitive. And the market opportunity for lithium sulfur is huge, and it keeps growing because of the increased use of drones and electric vehicle and even electric vertical takeoff vehicles. We have, yes, thank you. We have, hello? Hello?
Yeah, I'm here.
Is there a question?
No, I said 30 seconds.
Okay, great. Yeah. So we've received a lot of support from the National Science Foundation, the Air Force. Currently, we just concluded Air Force Phase 1, and we are actually looking for people that know stakeholders and customers within the Air Force and Space Force, because we are working on our Phase 2 applications. And any other support you'd like to provide will be much appreciated. Thank you.
Perfect. Thank you so much, David. All right, questions. Gavin, go ahead.
Hey, thank you for sharing. I just want to ask, where are you with your product right now? And yeah, how's the manufacturing and the commercialization of that product?
So currently in terms of R&D, so the result we have is actually power cell, 1 amp hour power cells that we actually fabricated, no coin cell. And that is the one that we are currently at 151 watts watt-hour per kilogram energy density, which is almost around this one that EV picture it is. So we are really, really good. And currently, this is actually our first integration of our cell actually to power a drone. There's actually a video that they want to waste time showing. So we actually have something commercially viable. And we are also in talk with some strategic partners like Adar Technologies that have better manufacturing capabilities, and then Eagle Picture. And so when it comes to integration, we have those partners that have better manufacturing capabilities to help us in getting in for any application that you're looking at. We are focusing on the set development. Like, for example, we were at 50, we moved to 107, we moved to 151, we want to get to 200. But even at this 151, we have a good cell already that can go into any system.
Got it. And can you go to the traction slide again, really quick? Got it. Have you worked with any pilots in the meantime? And have you spoken with any clients of when we have this type of pilot with these US drone manufacturers?
Yes. So we've spoken to we've spoken to many US drone manufacturers, and I think we have about 5 or 6 that are waiting to integrate our drone into the system and to be able to test. Yeah. One of the areas that we're working on even increasing is what they call the power density, the series performance. And then we also have a company that we work with called Alien, in which they have a battery management system that helps to optimize the performance of our lithium sulfur battery, for applications that require high C rate.
Got it. Thank you.
All right, Joe, you're up, and that's the last question for this one.
Yes.
Thank you.
So David, from the from the slide where you showed NASA's in use batteries, 153 is already above by a significant amount, if I remember correctly. What's stopping you from going and trying to sell to them if you already have a product that's better and you have the capability to produce it?
Okay, that's a great question. So you can see here where we show how we proceeded. So there was a time that we were at 107. So I think we're just about 2 months ago that we actually reached this 151. And currently, for the past 3 weeks, our team has been working on getting to 200. So it's a continuous improvement. And one of the things that I mentioned that we'll be in the Air Force Phase 1. And we'll be in there. And one of the things that we'll be doing even before we came to this meeting is speaking to Air Force people, showing that this is what we have. We've spoken with Lockheed Martin. We are working with them, and we still keep reaching out. So we are trying to engage. And that's why one of the asks is, do you know people that we need to be talking to so that this can be adopted and integrated into systems? There's a difference between you having a solution. There's another thing in getting it into applications. And so we are really looking into that. If we can get it into the military, that will help us to really bring the cost down and be able to help us with the commercial side. So that's why we need support in that area.
Perfect. Perfect. Thank you so much, David. Make sure to leave your information. Really appreciate having you. All right, next up we have Tello Trucks.
Can you guys hear me?
Yep, loud and clear.
Awesome. You can get a little glimpse of our shop behind us too.
That's awesome. We can't see your deck yet, though, so you know, in case you're.
What's that?
I can't see your presentation yet. If you have.
Nope, I'm sharing it right now.
Okay, perfect. Yep, now I can see it.
All right. Well, thank you everybody for having me. I'm really hoping to get some feedback as we go into our fundraising time in September. So definitely want you to ask the tough questions if you can. So what we do is fairly self-explanatory. We're building utility vehicles for cities. We built an electric mini truck, a crew cab pickup truck with Tesla range the size of a Mini Cooper. And you're probably thinking that, wow, that sounds like an expensive thing to do. But we've been in the automotive industry for over 2 decades between early Tesla, Aston Martin, Nissan, Ford, and GM. And we believe now is the right time to bring a vehicle to market at 1/10 the cost of other EV startups before us. So really the reason that we chose urban light duty trucks is because it's an extremely big provider of carbon emissions in the US. 10.5% of all carbon emissions in the US are from one thing, light duty trucks, and that's across all economic sectors. So if we could snap our fingers and reduce light duty trucks emissions altogether, we could reduce the carbon emissions in the US by over 10%. Now, we really are approaching this from a perspective of looking at the EV graveyard for the last 20, 25 years. I mean, Tesla did amazing things of bringing EVs to light, but it was an expensive project, and other companies have come after them and really had a lot of trouble getting to market, partially because they competed on a market that was over-indexed. You know, big trucks are over-indexed, and we'll talk about why big trucks exist in the first place, but really we wanted to go after a market that was unserved today. There are 2 million pickup trucks in cities purchased each year by fleet companies. That's over $200 billion spent per year on pickup trucks in cities. And if you talk to people that are working on fleet companies, we have MOUs and work with Waste Management, Target, and other companies, and the Air Force as well. They'll tell you these horrible stories about having to buy 20-year-old pickup trucks because they're the only ones that fit their resources, or buy a new pickup truck, completely destroy it by cutting off the bed and adding a bunch of third-party equipment to it and ruining the market value of their vehicle. And if you look on today in Silicon Valley, you can buy a 20-year-old small Ford Ranger for more than it was asking for originally. So really an underserved market in city pickup trucks for cities. The next big thing is capital efficiency. EV companies in the past have tried to make profitability at 50,000 vehicles per year. And we have a financial model that can get to profitability at 5,000 vehicles per year. This is low and mid-volume manufacturing. That's really only been possible because of the advancements made in contract manufacturing, the commoditization of EV parts, and the Inflation Reduction Act funds. And then on top of that, we're bringing a bunch of new technology to market that lets us build vehicles in the footprint we're describing. We have proprietary battery, safety, and packaging IP, and we're using a significant number of new softwares to virtually validate our vehicle without building very many prototypes whatsoever. And really, the market we're going after, size is a huge component of this. We are a crew cab pickup truck in the footprint of a Mini Cooper with all the capability of a Class 1 or Class 2A utility vehicle like an F-150. We already have $100 million committed in over from paid pre-orders, from over 2,000 paid pre-orders. We're working on 3 MOUs for work trucks, non-tactical military vehicles, because they have to get to zero emissions by 2035, and mid-mile delivery vehicles. We have a team of people that have been in the automotive industry for over 2 decades, on the very first Tesla team that developed the first battery pack for the Roadster, a team that myself, I developed the ADAS systems, the autonomous driving systems for that went into a lot of the OEM programs, and Ford, GM, and a number of other ones, Rivian, Lucid, and other ones. And we have a world-class designer that's well known throughout the world for his design work. He actually went to school with a bunch of the other leading automotive designers in the space. So the first big innovation we did was we cut off the hood of the vehicle, and we are replacing it with technology that was developed both for space systems for landing spaceships on the moon, in Mars, and also in the autonomous vehicle world for detecting and driving vehicles around autonomously. We're using it for a vehicle feature that's reactive to crashes. So we have an airbag that deploys on the outside bumper of the car using 3D imaging radar technology to detect collisions before they happen, saving both occupants and pedestrians. And on top of that, we have a number of internal safety features common throughout other vehicles, really geared at creating a whole symphony of safety for our vehicle that has no hood. We developed a battery pack that's 50% more space efficient than Tesla's and can be laser welded on a single shot from a single material on the top, which can be manufactured in minutes, not hours. So our battery can be built in situ in our vehicle shell, and it is about a fraction of the time and energy and materials necessary to build another battery. And that enables us to build a reconfigurable platform that can serve any work truck utility feature that we see is necessary in the future. So the big thing we're doing is vehicles at 1/10 the cost that other EV manufacturers have done. So profitability models at 5,000 vehicles per year, low volume and mid-volume contract manufacturing, homologation with fewer than 10 prototype vehicles, the state-of-the-art in tooling, die casting, and virtual validation, using the learnings from both the Detroit, Silicon Valley, and even European areas, and the commoditization that's only recently happened in the supply chain that we don't have to develop a lot of high-power electronics. And you might be asking, well, doesn't America want big trucks? Like, why? What are you doing here? Like, the truth of the matter is we actually can't have small trucks, not because Americans don't want them, but because the Environmental Protection Agency, the very agency meant to reduce carbon emissions in the US, has forced automakers' hands at building bigger vehicles. They come out with these requirements every year that shows that the fuel economy for each vehicle has to be getting better over each year, but it's all contingent on the size of that vehicle, the footprint. So what automakers did is they said, okay, I can no longer make a vehicle more efficient at the specific footprint it's at, so I'm just going to make it bigger. So that's why today's F-150s are the size of the F-350s of 20 years ago. They cannot make their vehicle more efficient, so they make it bigger. But we're electric, we're using new technology, and we don't have that problem. So we can come in at a very much smaller footprint and don't have to worry about the Environmental Protection Agency. So our 5-year plan is to get to profitability at low volume, get to profitability at mid volume, and then scale to high volume. So right now we've already raised $1.6 million. We're gearing up for a fundraise here shortly, where we raise our $10 million seed, and which will get us to validation and will get us to delivering our very first vehicles. Thank you.
Thank you so much, Jason. All right, opening the floor for questions. Matt, go right ahead. You were the fastest.
Yeah, Jason, thank you so much for that. So my number one question really has to do with range appetite. So, given your focus on urban environments, smaller crew cab vehicles, like what type of range and payloads do these systems need for Class 1, Class 2A vehicles that you're expecting?
Yeah, so I'll use waste management as an example because it's one of the biggest MOUs that we're working on. We have 20,000 F-150s that do work in cities. They have to go from their Los Angeles location, their base is about 100 miles away from the downtown Los Angeles area. So they drive 100 miles in each day, go to 150 different condos to pull out trash bins out of the underground parking lot, bring them out to the street so the garbage bins can actually offload them into the street and drive back. So they drive about 200 to 250 miles round trip, and they pull 2,000-pound trash bins out of dumpsters and do that about 150 times each day. It's a good example of that particular application needing a battery pack that has 106 kilowatt hours like we do in the tiny footprint we have.
Wait, just to be certain here, you're not talking about like the Class 6 refuse trailers. You're talking about
just they pull. They have F-150s. They equip with a big. They call it the Stinger vehicles. They have 2 forks in the back. They pick up these trash bins out of underground parking garages. They pull them out to the street, and then the Class 6, Class 8 vehicles take them and offload them into their dumpster bin.
Okay, I understand. Thank you.
Absolutely.
Perfect. Tito, you're up.
Yeah, I was gonna ask, you have a contract for the cells. What kind of chemistry you're thinking of using, and how is it how is it patented to you? That was it developed in-house?
Let me tell you a lot about that. So we use off-the-shelf 2170s, nothing special about them, same cells that everyone has access to. The technology really exists in the battery pack. So we have a special type of material that lays atop the cells and gets laser welded in a single shot that can do all positive, negative terminals, all thermistors, and all data lines. And it's only from the top of the cells, and it's less than a millimeter thick. We can extract all the heat out of the bottom of the pack in a solid state manner using technology developed for semiconductor. And that technology is active cooling, but it doesn't have any fluid flowing through the battery pack, and it's less than a centimeter tall. So the real efficiency here is that we're only, with these 70 millimeter tall cells, the entire battery pack with an enclosure is only 100 millimeters tall. Extreme space efficiency.
Cool. Thank you.
Yeah, thank you.
Leisa, you're up.
Just a quick question about the weight distribution. I drive a pickup, and it's very front heavy, right? Which, and it's rear wheel drive, so it's kind of a pain unless I put four wheel drive in the snowy season. So, and it looks like yours actually sort of solves that problem. So I'm curious about, instead of having a giant engine in the front of my pickup, it looks like you've got a better weight distribution just in terms of, how the truck performs.
Yeah, the powertrain for each front and rear is 62 kilograms. That sits directly in front of each rear axle. That's where that center of mass is. And then our entire battery pack weighs about 750 kilograms and sits directly in between each of the front wheels. So it's almost a perfect 50-50 distribution.
Good stuff. All right. Lisa, unless do you have another follow-up? No? Okay, perfect. Beautiful. Thank you so much, Jason. That was a really interesting presentation. And yeah, feel free to leave your info. Everyone bear with us. We have one more presentation today. Newborough will be presenting, some blue laser technologies, I'm assuming, Adam. Go right ahead whenever you're ready. All right.
Okay. Asher, is that me?
Yep, you're up.
All right, sorry about that. I just in the middle of something else. Let me share my screen. So, little background on Newborough. We've been in business for about 7 years. We currently provide, can everyone see that? We currently provide lasers into battery manufacturing, 3D printing, and quite a few display applications as well. And what we're doing is continuing to explore how this blue laser technology can continue to be used in some really interesting applications. And my background is fusion energy, and I don't know if everyone's aware of this recent breakthrough, but basically Lawrence Livermore has now established a path for inertial confinement fusion that is essentially what I consider proven. If they had done when they did the first test, I was like, okay, that's very interesting. But when they did the second test, it tells you that there is a path to make this possible. However, a commercial reactor is highly dependent upon the laser technology being used to drive these ICF pellets. And as I started looking at the technology that they're using today, which I'm very familiar with, been working on it for many, many years. And I started thinking about the blue technology we have, an idea occurred. And this is really talking about a path to fusion that could be commercial. So I don't know if people are familiar with the National Ignition Facility, but this is what it looks like on the right. It's a large facility because when they started working and designing this, they began with technology from 2020. year 2000. It's now 2023. We have had 23 years of laser technology development over this time. And the other thing you'll notice on the left-hand side is the target shot count. In 2023, they've had approximately 274 shots. Well, in order to make a commercial fusion reactor, you have to be able to do this between 10 and 100 times per second. They're not anywhere near that level with this technology they're using today. And a new approach is needed, something that can operate at extreme rep rates with high efficiency and high reliability and performance. So I went back and looked at the Lawrence Livermore ICF reactor requirements. And this was a study they did several years ago. They called it High Life 2. And it's really based upon several definite requirements. The wavelength of the laser being used. And the reason is because they have to couple it into a gold target and drive the fusion reaction. The laser power you have to achieve, the number of shots per second required for a reactor, and the total energy of the laser driver. And as you can see on the right, there is a path using Nuburu's blue laser technology, which we have all the confidential and proprietary rights to, that can build an ICF laser fusion driver based upon this blue laser technology. And the reason it works is because we'll have pretty much the same absorption on the target as the 351 nanometer Guelph. We can produce the same peak power levels for the durations that is needed. And we can do it at high rep rates because the technology we have is very compact, much smaller than what they use today, and can be operated at very high repetition rates. So this is really a different approach to how to design a laser for a commercial nuclear fusion reactor. Not going to go into a lot of details because there's a lot of IP being filed around this right now. But essentially, this is my executive team at Nuburu. Myself, as I mentioned, my background is nuclear and plasma engineering out of the University of Illinois. And on my staff, I have physicists as well as chemists. In terms of being able to drive the interest in this technology, we've just added John Bolton to our board of directors, which gives us direct access into many of the government's interesting programs run by DOE. We also have an entire range of DoD applications we're currently pursuing. And again, he is going to be instrumental in us making those connections. As I mentioned, I was going to keep this short, but we've developed the fundamental technology required to do this. It's ideal for a commercial ICF reactor. And we're looking to raise $100 million in funding to transition this from where it is today to actually something that could be deployed in the near future. And with that, again, very short. Thank you very much.
Thank you, Mark. Thank you. All right, opening up the floor for questions or comments. I know that a few people had to drop, but
that's okay.
I would love to hear a little bit more about your U.S. Air Force traction. If you're willing to share a little bit, I'll kick off the question.
Well, that's an area that we're teamed with GE Additive right now. And GE Additive and us are developing a high-speed, high-volume 3D printer. Our target is approximately 10,000 cc's per hour, which is over 100 times faster than what can be done today. And the only reason you can do that is because of the blue laser technology. That is a unique feature that can be accomplished because of the high absorption of materials from the blue laser. We've put out several press releases on that. That program is doing fantastic, and we expect that to be a future path for many of the additive manufacturing developed by our partner.
Awesome. Well, perfect. So Mark, I don't think there are any other questions, but feel free to leave your information in the chat, and we'll also, we'll have the recording as well. So Thank you so much. Yeah. Thank you so much for presenting. Thank you for everyone who joined, all the panelists and all the companies. I know that it's been a really interesting showcase, a lot of really interesting technologies. And I think some of the most interesting in my opinion so far. Obviously I'm very biased though. Thank you everyone for joining, and feel free to stay tuned. We're going to send a follow-up with the recording. And again, if you have any questions or want to get connected with a company, if you did not catch an email, don't hesitate to turn to me. I am more than happy to provide it. And thanks everyone for staying on, and have a good rest of your day, and enjoy the Thursday.